Hey, welcome back to the second part of this amazing Python course. We divided this course into two parts, as YouTube does not allow uploading video if length is more than 12 hours. I would recommend to watch the first part, then come to the second part. So I will put the first part link in the description of this video. So have you done that? If yes, that's great. Let's continue our learning journey. Before that, make sure to hit the thumbs up and the subscribe button as well. And if you are feeling generous, you can buy me a cup of coffee or become a patron. So without wasting any further moments, let's dive in. In this video, we'll explore Python's built-in math module, a powerful library that helps you perform mathematical operations like square roots, powers, trigonometry, rounding, and much more. So step 1, we have to import the math module. So we write import math. This gives you access to many mathematical functions and constants. Now if I write the print statement, and here I can write square root of 16, and that is math dot square root means sqrt, and here we can pass 16. Now if I run the code, you'll see it prints square root of 16 is 4.0, means 4 actually. So behind the scenes, it uses efficient algorithms to calculate the square root and always returns a float. You can call the int method to turn this into an integer. Now let me show you some mathematical operations. For example, if I write here 2 raised to the power 3, and here if I write math.pow, we can give 2, 3 as argument, means 2 raised to the power 3, and if I run the code, you will see it prints 8.0, means 8. Then let's have some more example. So print floor of 3.9 colon, and here I write math.floor and pass 3.9, it will convert 3.9 to just 3. So if I run the code, you'll see it prints 3. It just round downs. So no matter what you give after the period, it will just have this one, means it will round down the period part value. You run the code, again it is 3. And here if you write the print statement again and just write ceil of 3.1 colon and comma math dot ceil, and let's give 3.1, so it will round upward, so it will make this 4. If you run the code, you'll see it prints 4. No matter what you give afterward the period, it will always gonna round up. So if you run the code again, you can see the output is 4. Now we can have the value of pi and constants as well. For example, if I write here math.pi and run the code, you'll see it prints 3.1415 and it goes on. I can write here print then math.e, it is a constant, and if I run the code, you'll see it gives the value of e, which is 2.7182. We can run some trigonometric function as well. So if I write here the print statement and let's write cosine of 0, and if I write here math.cos and just pass 0, let me give the colon here. Again run the code, you will see cosine of 0 is 1. Then we can have all the trigonometric functions here. For example, sine. So if I write the print statement, and here if I say that sine of pi divided by 2 colon, and here I can write math dot sine, and inside this method we can again call math dot pi for the value of pi. Then we can divide the value of pi by 2 and we can pass the result in the sine method. Now if I run the code, it will give the result. As you can see, the value of sine pi by 2 means the 90 degree is 1. You can get the degrees as well. So if you write math.radians and pass these statements inside math.radians and run the code, you'll see it gives the degree. And we can do some logarithm as well. So here I can write print then log base e of 10 and just write math.log and we can pass 10. And again we can write the print statement and log base 10 of 100 comma math.log 10 and we can pass 100 here. Now if I run the code, you'll see first it prints log base e of 10, which is 2.30 and some values, then a log 10 of 100 is 2.0. So log x is natural log, which is base e, and log 10x is base 10 log. Now we can get some more complex mathematic operations, for example GCD or LCM. GCD means greatest common divisor. LCM is used for finds the least common multiple. So for that you can just write the print statement, and if you give math.gcd and pass 12 and 18, it will just print the largest number that divides both. So if I run the code, you'll see it prints 6. So we can divide 12 and 18 by 6. So it is the largest number which can divide both of them. That's the meaning of GCD. We can print the LCM. So print math.LCM and pass 12 comma 18, and if I run the code, you'll see it prints 36. So LCM finds the least common multiple. So that was the math module. I hope you understood everything I discussed in this video. So that's all for now. See you in the next one. Have you ever needed to search a phone number, validate an email, or extract data from text? That's exactly where regular expressions or RegEx comes in. In one line, RegEx is a powerful tool to match, find, and manipulate patterns in text. Let's break it down together in the simplest way possible, starting from the basics with examples you'll actually use. So what is RegEx? Think of RegEx as a special language for text pattern matching. So example problems RegEx can solve is it can check if an email is valid or not, if a phone number valid or not. It can extract all numbers from a paragraph, remove special characters from text, and more. Once you get the hang of it, you'll use it everywhere. To work with RegEx, first you import the RE module. RE is a built-in module in Python. We don't need to install anything extra. Just import it and start using. Let's say I have a variable called text equal a string, and that is my phone number is 017 and 1 2 3 4 5 6 7 8. Now to find that phone number we can declare a pattern. So pattern, by the way, you can name this anything, and here we can say that R, then in double quotations I can write / to indicate it is a regular expression pattern, then D, and we want to find numbers of 11 digits. So D means digits. Okay, then we can have match this variable, and we can write re dot search, then we can pass pattern means this one, and the text from where we want to find. Okay, then we can write the print statement and say match found, and we can call match dot group. If match, else we can say that there is no match. Now this /n tells Python that we are trying to find digits, means 0 to 9, and this 11 tells match exactly 11 digits. This R means raw string tells Python to treat / literally, and this re.search finds the first match in the text, and we are telling to group the match if found, otherwise just tell that no match. If I run the code, you will see it prints match found and the phone number. Behind the scenes, Python goes through each character until it finds 11 digits in a row. Okay, we understood the search method. Now let me comment this code and let's try to understand the find all method, which finds all the matches using the regular expression. So now we will see the find all method. Now let's say again we have a variable called text. There we have this string. For example, it has this contact 017 1 2 3 4 5 6 7 8. Okay, then we can give a comma, then we can have this backup phone number and 018 1 2 3 4 5 6 7 8. Okay, now using the find all regular expression method, we can match both of them. With the search, we just match once, and here we write matches equal re dot find all, and here we give the regular expression r, then double quotation / d and 11 digits. Then we can give the text, and in the print statement we can say that all numbers comma matches. Okay, now if I run the code, you'll see it prints both numbers as a list. Unlike search, find all returns a list of all matching patterns. Let me comment this as well and see the sub method. Let's have this variable called text, and there we have a string which is Python is amazing, then Python is everywhere. Now using the sub, we can replace. So what I can do is I can write updated underscore text, then equal re.sub, and then I write the r, and in double quotations I say that replace Python with Java. Okay, so and then we pass the actual string where we want to do the replacement. So we are telling that find Python in the text string and replace all the Pythons, no matter how many times is there in the string, with Java, and just write the print statement and pass updated text. Now if I run the code, you'll see instead of printing Python is amazing, Python is everywhere, it prints Java is amazing, Java is everywhere. So re.sub, this method is like find and replace. It finds all the matches of the pattern and replaces them. Let me comment this code as well and see the use case of the match method. Let's have the variable text which contains hello world, and we can say that if re.match, and there if I say r, then pass hello in the string. If this matches in the text string, then we want to print that string starts with hello, and if it does not start with hello, means else, we want to print does not start with hello. So now if I run the code, you'll see string starts with hello. Unlike search, match only checks if the start of the string matches. Now let's have a real world use case of regular expression. So we use regular expression to validate emails. So let's see how we can validate an email. Let's say we have a variable called email equal example at 123@gmail.com. Then let's say we have a pattern. There we define this regular expression. It will be quite long. Here we give this cap, then say that email can have letters from lower a to z, then capital A to capital Z, then 0 to 9, then dot. It can have the underscores as well. Then we close the square bracket and we say that plus it must contain @ sign. Then after @ it will have this provider. So here this can hold letters from A to Z. Let me close this square bracket, and after that we give a plus, then a backward slash, then dot. Means we say that after the provider we will have a dot, and then we can have .com or .net. So for that we'll say that we allow A to Z. For the closing square bracket we say that those should contain 2 or 3 letters, I guess. Then we give the $sign. Now this regular expression is quite long. You don't have to memorize this. You just have to use Google. We never memorize regular expressions, we just Google them. There are many sites which generates regular expressions. So regular expression to validate email. If you search, there will be hundreds of sites where you can get a regular expression, and you can use ChatGPT or Gemini or other AI tools as well. And you should not memorize it actually. Just understand how the process works. Now after writing the pattern, you can say that if RE means this package we imported, and dot match, then we give the pattern, comma, and the email means this variable. Okay, so that we give this colon to get a block, and there we say that print valid email, else just print invalid email. Yeah, now if I run the code, you'll see it prints valid email. But if I remove the @ sign and run the code, you'll see it prints invalid email. So I hope you understood how to use regular expressions in your code and why we use it. Now you can ask that, do I need regex for everything? Not at all. Use regex when you need pattern matching, or you need to validate user input, or you want to clean or transform text. If you are just checking if a word is in a string, simple Python methods like .find or in might be better. Now you can ask, why not just use the split or the replace method? Now it's a great question. Those methods are great for fixed strings, but regex allows patterns to match any digit, match 3 letters followed by 2 numbers, match phone numbers or dates with different formats. Now there are many regex symbols. You can just look to them. So if you go to Google and search for Python common regex and just open this W3 School site, you'll see the Python regex symbols. Means in general regex symbols, because regular expressions are almost same in all the programming languages. Okay, so you can just read this article for once. You don't have to memorize anything from here. So that's all for now. See you in the next one. So far you have written a lot of Python code in your files. But what if you want to reuse your code in multiple projects? Instead of copying and pasting, you can create your own Python module, which is just a file with useful functions you can import anywhere. In today's video, we'll learn what a module is, how to create one, how to use it in another file, and how Python finds your module. So let's get started. So the first question is, what is a module? A module is just a .py file that contains functions, variables, or classes. Python has built-in modules like math or datetime. We can import them. So import math, then we can say import datetime. we can import these modules and use them. Now you can also create your own module with your custom logic. Now as you can see, the current file we are working in is the file1.py file. If I open the file explorer here, and here what I can do is I can create another Python file with the name myutils.py. Okay, now here I can create a function, so def greet, and we accept a parameter called name, and here we just tell return, then string formatting, and we say hello, and inside curly braces we say name. Now we can have another function, so def square, and there we accept a parameter called num, and here we just return num into num. So you now have two reusable functions. The file becomes your custom module. Now what I can do is I can go back to my file1.py file and remove this code, and here I can say that import myutils. So we are importing the code from this file. Okay, and here I can write the print statement and just write myutils dot, as you can see PyCharm is suggesting me the functions, so I can call the greet function, and here I can give a argument like gojo. As you can see, we don't have the greet function in this file, but if I run the file, means the file1.py, it says hello gojo, but this function was in this file. So we are successfully using function from this file in this file. Okay, now we can write the print statement again, and here we can say myutils dot square, and we can pass 4 as argument, and if I run the code, you will see it prints 16. Now as you can see, we are importing the whole module, means the myutils file, and every function or object or classes this file contains, we are importing everything from this file inside our file1.py. But you don't always need to import the whole module. You can import only what you need. So for example, you don't need the square function, you just need the greet function. So you don't need to import the whole module. Instead of that, from that module you can import a greet. So you can write from myutilities import greet. Okay, and now instead of writing myutils.greet, just write greet. So you are telling Python, don't import everything from myutils, just import the greet function. Okay, and then you are just executing that function. So if I run the code, you'll see it prints hello gojo. Now if you write here Naruto and run the code, you'll see it prints hello Naruto. So behind the scenes, Python looks for myutils.py in the same directory or in the Python path, then it loads the file and makes the functions available. Now as you can see, we are writing myutils, means the same of the file name what we have here. The file name is myutils.py, so we are writing here myutils as it is, but you can write this differently. What you can do is you can just write import myutils as mu. So this makes it shorter and sweeter. Then you can write mu.greet. Okay, now if you run the code, everything works as expected. Now you can ask why create modules. That is because it helps reuse code in different projects, keep files clean and readable, so you can put these two files in a separate folder. For example, in a utils folder, as you can see, there is so many files we have created, but if you put this file inside there in another folder like this, then it becomes easier to access and manage the files, and it becomes easier to find the utils files. So in this process, you can organize all the files here in this project. It also makes testing easier. It also helps share your code with others. And another question you can ask is, where does Python look for modules? So Python can look for modules in the current directory or built-in paths or any folder listed in the Python path environment variable. If Python can't find your module, it throws module not found error. So if you delete this file and try to run this code, it will say that module not found error. Then you can ask that, can a module import another module? And the answer is absolutely yes. Modules can import other modules like built-in or custom modules. Just make sure the paths are correct. Now let me give you a practice challenge. So create a module called math_utils.py, and that includes a function to check if a number is even. So function to check if number is even, and create another function that checks, that calculates factorial. Then import and use them in your another file. Make sure to do these tasks. So that's all for now. See you in the next one. Today we are going to uncover something super important that happens behind the scenes in loops, and that is iterators. You have used for loops before, but have you ever wondered how Python actually loops through a list or a string or a tuple? That's where iterators come in. So first of all, what is an iterator? An iterable is anything you can loop through. Lists, tuples, strings, dictionaries, all are iterables. For example, I have a list called my_list, and there we have these values. For example, 10, 20, then 30. And after that, we can say that for num in my list, we want to print num. Okay, if I run the code, it prints the numbers. We have done this before, but here's the truth. Behind the scenes, Python does this. So if I comment this for loop, then if I write iterator equal, then I call the iter method and pass my list, then I can just print the next keyword, means the next method, and just give the iterator. And I can do this for 3 times because I have 3 numbers. Now if I run the code, you will see the exact output. So when you loop through a list, behind the scenes, Python does this. So iter method turns the list into a iterator. Then the next method gets the next value from it. Once the values are done, calling next again will raise a stop iteration error. So if you call this next again, run the code, you'll see it throws error stop iteration. Okay, so remove this line. So an iterator is an object with 2 methods. If you ask that what is an iterator, and the methods are underscore underscore iter, underscore underscore, then parenthesis, then underscore underscore next, underscore underscore, then parenthesis. Any object with these 2 is considered an iterator. Lists are iterables. They become iterators when you call iter on them. So behind the scenes of a for loop, so let's see what happens behind the scenes of a for loop. So if you write here for x in this list, which has the value 1, 2, then 3, then print x. So for this code, behind the scenes happens is, first we get a variable called nums 1, 2, 3, then we get another variable, for example it, then we call the iter method and just pass nums, then we write the while loop, so while true, then we write a try and except block. The try block, we say that item equal next, then we give the it, and after assigning it to the item, we just print the item. Now before we were manually doing this step, so when we wrote for print statement, it throws the stop iteration error, but we can handle that here in the while loop with the except block. So except stop iteration, and here we just can say that break the loop. Okay, now if I run the code, you will see it prints 1 2 3. Okay, so this 1 2 3, and this 10 20 30 is getting printed for the previous example. Okay, now you can create your own iterator, but I don't think that is much necessary to understand at this point, so I'm gonna skip that. If you want to truly understand that, let me know in the comment section. I will create a video on that. I don't think it is that much necessary. So let me answer a few common questions some beginner ask. So now you can ask that what's the difference between iterable and iterator. So iterable, so first if we talk about iterable, I'll say that you can loop over it like list or tuple. And if you ask about iterator, I'll say that you can get one item at a time using the next method. Now the next question arises, and that is, what happens when the loop is done? The answer is, when there are no items, Python automatically catches the stop iteration and exits the loop. And the last question you can ask that, can I loop over a custom class? Yes, just define these two methods and you are good to go. You can always loop over a custom class, and you can also create your own iterator, but I don't think that is necessary at this point. So I hope you understood the topics covered in this video. So that's all for now. See you in the next one. Hey everyone, welcome back. In this video we are starting a super important part of Python, and that is object-oriented programming, or OOP. So it's OOP, which stands for object-oriented programming. If you want to write clean, scalable and real-world level Python code, then object-oriented programming is a must-know. So let's understand this in the simplest way possible. So first of all, what is object-oriented programming? So let's explain like a story. So imagine you are creating a game. In the game, there are many players. Each player has a name, a score, and some actions like jumping or running. Now, if we store each player as a bunch of separate variables, it becomes messy. So for example, if I write here like name 1 equal Tom, then score 1 equal 100, then let's say we have another player and that we store in name 2. His name is Bob and score 2 is 120. So if there is more players, the code becomes so much big and this becomes unmanageable. So that's where we want to create a template or blueprint for what a player should be. The blueprint is called a class. Now let me tell you another example without object-oriented programming. So for example, we have a variable called name equal Alex, then age is 25, and we have a function called greet, and there we want to print hello and the name. Okay, and let's call the greet function. Now if I run the code, you'll see it prints hello Alex. Here name and age are global variables. I hope you understand global or local variables. We talked about that in our scope video, and this greet is a function not tied to any specific person. This approach works for tiny scripts but becomes unmanageable as you build more features. Now let's see how we can do this with object-oriented programming, or OOP. Now first of all, in object-oriented programming we have a class. So we write the class keyword and then we give a name for that class. For example, in this case person. Okay, and inside that class we have a special function which is called constructor. So as it is a function, we write the def keyword, then here comes the interesting thing. When you define the constructor, you must name this underscore underscore init. Okay, now in the parameters we have a self. Now this self parameter refers to the object that is being created, and then after having this parameter in a constructor, we have this parameter. Then we can have other parameters as well, as many as we want. For example, we can have name, then we can have age, okay, and you can define more parameters, doesn't matter. Now here we can say that self dot name equal name. So then after that we can write self dot age equal age. Don't worry if you are not understanding that much now. I assure that you will understand step by step as we move forward. Okay, now we have our constructor function. We can have other functions as well, the normal functions I mean. So here I can write def, then a function called greet, and here we have this self parameter. Then we can do just print hello, then self dot name. Okay, now let me give you more explanations regarding this code. So this class person creates a blueprint called person. It's like creating a template, and this dash dash init dash dash is the constructor. It runs automatically when we create a new person. We'll learn how to create a new object a few moments later. Now this self.name means this object's name, means the object created with the class person, so the current object's name, and this self refers to the object that is being created, and this greet is a method tied to each object. So before proceeding to understand it better, let's create an object. To create an object, we first take a variable. For example, let's call this p1 equal, then we write the class name which we created here, so person, and in between parentheses we give the params. Now we don't have to pass the self param, but we have to pass name and age in order. So first we pass the name Alex, then we can pass the age, let's say 25. Okay, now we can say here that p1 dot greet, because we created this p1 object with the class person, and there we have a tied function there, and we can call that function using the object because the function is tied to this object. Now if I run the code, you'll see the same output. If I change the name to Naruto and run the code, you'll see it says hello Naruto. So again, p1 is an object or instance of class person, and Naruto is passed to name param, and 25 is passed to the age param. And when we call p1.greet, it uses the values inside that object. So we created this object with the values Naruto and 25. So when we call greet, it uses these values inside that object. Okay, now let me comment this code and let's take another real world example. So let's create a class for car. Okay, now here we have our constructor which is dash dash init, then here we have this self parameter, then we can have another parameter called brand, then color. Okay, and here we can write self dot brand equal this brand, which we are gonna pass while creating an object. Now here we are gonna say that self dot brand equal this brand, which we are gonna pass while creating an object. Then we'll say self dot color equal color. Now this function is done. We can have another function called drive. There we have this self parameter, and here inside this function we can print with the string formatting obviously, and here we can write the, in curly braces we can write self dot color, then a space, and again inside curly braces we can write self dot brand is driving. Now the class is complete. Now with this class we can create some objects. For example, we can create car1, and here we're gonna use the car class with the capital C, and here let's say the car brand is Toyota and the color is red. So we are passing Toyota to this brand and color red to this color param. Now we can have another object, car2, use the car class, and first of all the brand is Tesla and the color is white. Okay, so as you can see in object-oriented programming, everything is kind of object. So as we can see in object-oriented programming, we mostly work with objects. So these all are objects. Now here we can write car1 dot drive, and we can write car2 dot drive. Okay, now if I run the code, you'll see the red Toyota is driving, then in the next line it is saying the white Tesla is driving. So again the car is our blueprint or template. Each car object, means this, gets its own brand and color. Drive method is attached to each car and uses that car's data. And car1 and car2 are independent objects that don't affect each other. Now there are some key object-oriented terms in beginners should know. So first of all, they should know about class, then object, then constructor, then method, and then attribute. So class is the blueprint or the template, as you can see. Object, these are objects we create with that blueprint. Then we have constructor, the function. It is a special method or function to initialize data when creating object. Then method, now this is easy one because any function inside a class we call that a method. Then attribute, so attributes are data stored inside an object. For example, these are instance attributes. Okay, now it's practice time, so it's your turn. So create a class called animal. It should have a name and sound. Should have name and sound as parameter. Then add a method or function called makeSound that prints the sound. Okay, now pause the video and try to create this class and the objects and the methods by your own. Okay, have you done that? If yes, then very good. And if you couldn't do that, let's implement that now together. Okay, so let's create a class called animal. So class animal, and there we have this constructor, so dash dash init, and here we give name, then sound as parameter, and in the constructor we say that self dot name equal name, then self dot sound equal sound, and lastly we have to make a function called makeSound. So def make underscore sound, and here we have to print some string with string formatting. So here we're gonna say that self dot name says self dot sound. Okay, now let's create some object with that animal class. So for example, we have an object called dog equal, and let's use that animal class, and here let's pass dog as animal name, then how a dog call or make a sound. So for example, it makes a sound like woof. Okay, and after that we can just write dog dot make sound, so we can call that method. Now if I run the code, you will see it prints dog says off. Okay, now we can have another object called cat, and let's use the animal class, and here the animal name is cat and the sound it makes is mew. Okay, so now we can say cat dot make sound. Now if I run the code, you'll see first it prints dog says oof and cat says mew. Now let's discuss some questions that beginners ask. So first of all, they ask that what's the difference between a class and object. So as you can see, class is a template or blueprint, and an object is the actual product created using that blueprint or template. The second question is object-oriented programming or OOP necessary? The answer would be not always, but it makes your code cleaner, organized, and easier to extend for real-world projects. And the third question is, what is self? So this one. So self refers to the current object. It lets the object access its own data. So when we work with dog, then self refers to dog. When we work with cat, then self refers to the cat. And the self lets the object access its own data. For example, this when working with dog and this when working with cat. So that was your first step into the world of object-oriented programming. You now know what classes and objects are and why object-oriented programming is useful. In the next video, we'll learn how to build the classes and objects in more detail and start building real-world examples. If you found this useful, like, share, and subscribe, and see you in the next class. Welcome back. In the previous video, we got introduced to object-oriented programming. In this video, we are diving deeper into two most important parts of object-oriented programming, and those are classes and objects. If you are a beginner, don't worry, we'll take it step by step with easy examples. So let's get started. Now, what is a class in Python? So first of all, class, though we have a look of class in our previous video, but let's discuss it more because it's a vast topic and object-oriented programming is widely used in enterprise level softwares. So a deeper understanding is necessary. A class is like a blueprint or a template for creating objects. Think of it like an architect's design for a house. You can use the design to build multiple houses, right? That's exactly what a class does. You use it to build multiple objects. Now, for example, to write a class or define a class, we write the class keyword and then we give a name. For example, student in this case. This is the simplest class possible. Right now, it doesn't do anything, but we can use it to create student objects. Let me write here pass so the error goes away. So again, it is not doing anything right now, but we can create objects with the student class. Now before that, what is an object? So object. So an object is an instance of a class. It's like actually building a house from the blueprint or the design. For example, here we can write s1 equal student. We are using that class, and here we can just write the print statement and pass s1, that object actually. So if I run the code, you'll see it prints dash dash main dash dash a student object at and this weird kind of thing, which is a memory location. So here s1 is an object created from the student class. Okay, so if you run this, Python will show something like this, and this confirms an object was created in memory. So let's add some properties to the class. Let's give our student class some data like name and age, and define how to set them when we create an object. So for that, let me remove this pass, and here we write our constructor. So dash dash init dash dash self as parameter, and we'll have two more parameters, name and then age. Then I'm gonna write self.name equal name and self.age equal age. Now you are seeing this warning because we have to pass name and age to create the student object. because dash dash init dash dash is a constructor method. It's called automatically when we create an object, and self.name and self.age are called attributes of the object. Now the self refers to the current object being created. So we are creating this object s1. So to use that object's data with referring with self, we have to pass the data, and that's when we give a name, for example Gojo, and age is 18. Okay, now instead of printing s1, we can print s1 dot name, then print s1 dot age. Now if I run the code, you'll see it prints Gojo and 18. So we created a student named Gojo who is 18. We accessed his data using the dot notation, as you can see with dot notation. Now this constructor is a special method. Now let's add a normal method here, just like how functions are used for tasks, and we can define methods inside a class to let the object do something. So let's say the method name is introduce, and inside that method I can write print, and with some string formatting, let's do my name is self dot name, then end I am self dot age years old. Okay, now we can use that method. So after these print statements, we can write s1 dot introduce. Now if I run the code, you'll see it prints my name is Gojo and I am 18 years old. Now like this, we can create as many as objects we want, for example s2, and again we can use the student class, and student name would be Naruto, and age, let's say 25. Then we can do s2 dot introduce. If I run the code, you'll see again it prints my name is Naruto and I am 25 years old. Now it's time for a question answer session. First question can be, what's the use case of a class? So the answer would be, it lets us group data and functions together in one reusable structure. So this class gives a super cleaner structure or a reusable structure to group data and functions. As you can see, these attributes data and these functions are there in the student class in an organized manner. Then again you can ask, what's an object? Now an object is a real example created from a class. Then what is self? Self refers to the current object. So when working with s1, self refers to s1. When working with s2, self refers s2 and its data. Now you can ask, from a class how many objects we can create? The answer is, one class can create hundreds of objects with different data, and even million if you want actually. Now let me comment this code, and it's practice time. Okay, so practice time, it's your turn. Create a class named book. It should have title and author as data. So title and author as data means parameter. Okay, then add a method called describe that prints them. That prints them means the title and the author. So pause the video and try to implement this. So have you done that? If yes, then great. If you couldn't do that, let's implement that together now. So first of all, let's have a class called book. Now here we have a constructor underscore underscore init. We have this self parameter, then we have title and author, and here we can write self dot title equal title, then we can write self dot author equal author. Now we can define a function, and that is describe, and inside that function or method we print self dot title is written by self dot author. Okay, now if you run the code, it won't do anything because we created the design. Now from this design we have to create the objects, so let's create them. So first of all, let's have a variable called b1 equal, then let's use the book class, and here let's say the book title is Python basics. Okay, and let's say the writer is me, Adil, though I have not written a book yet, but in future if I, and here we can just write b1.describe. Okay, let's call this method, and now if I run the code, you'll see it prints Python basics is written by Adil. So awesome, you now understand how to create your own classes and make objects in Python. This is the base of object-oriented programming. In the next video, we'll explore constructor more in detail. Hit the like if you learned something, and see you in the next lesson. Though we covered constructor in our previous videos, but I think this special method deserves a special individual video. So let's understand a constructor more in depth. What is it, what it does, and why it's important, and how it helps us write clean and powerful code. So let's begin. So what is a constructor? What is a constructor? A constructor is a special method that is automatically called when you create a new object from a class. In Python, the constructor method is named --init --. So let's take a real-life analogy. Imagine you are baking a cake. When you create a new cake, you always mix flour, eggs, sugar first. That's the constructor part. It prepares your cake. Similarly, Python prepares the object when you create it using --init --. Now, why is a constructor useful? It is useful because it allows you to set up your object with data immediately. So every object starts with the right information. Okay? Now, if you create a class, for example, student, and there, if you do not define a constructor, let's see what happens. So let me write a normal method. So def set underscore data, and here we get the self, which refers to the object we work on. And let's have some more parameters, for example, name, then age, and in the function we can say that self.name equal name, then self.age equal age. Now you are seeing these squiggly lines. Let's ignore them for this moment. Let's see what happens actually. Now we have this class, and let's create an object with that class. For example, s1 equal student. Okay, now as we don't have any constructor, we don't have to give the data or attributes right away. Instead of that, what we can do here is we can write s1 dot set data, this method we created, and here we can give the name, for example, Gojo, and the age is 18. Okay, now if I write the print statement and pass s1 dot name and run the code, you will see that this works. But you have to manually call set data every time. What if you forgot? Because you are calling this method to set just the data. First of all, you are creating that object, then you have to add another line, call another method to just set the data. But if you use a constructor, for example, if you make this --init --, then this line is showing error because we don't have that set data method now. So let me comment this. Now when you give a constructor, you can't create an object without these parameters. It will throw error. In the previous case, when we didn't define a constructor, we could actually create an object. After creating that object, we set a data. But when we have a constructor, it won't allow me to create an object without the data. So it is a must that you have to give the attributes or the data to create an object. So this becomes stricter. So I have to give there Gojo, then 18. Now if I run the code, you will see everything works fine. So this init means the constructor is a special method and we don't have to call this manually, it gets called automatically. And in a constructor, which parameters we expect, we must provide them while creating object, otherwise it won't allow us to create an object. If I show you that if I remove these and just try to run the code, you'll see it throws error. Okay, but if I make this comment and uncomment this line and rename this constructor to set data to make this a normal function, then I have to write s1 equal student, and we are just creating an object without any data. So if I run the code, as you can see, it is not throwing error, but we must have a name and age. We are not providing those data and we are still able to create an object, but that should not be the case. We should get error, because if you somehow forget this line, then try to print s1.name and run the code, you'll see error. So this will cause unintentional errors in your program. So it is a best practice to use a constructor in these cases. So let me go back to the constructor example. Okay, now if I run the code, it works perfectly fine. So again, this is a special method called automatically, and self refers to the current object, and name and age are parameters which data we pass while creating objects. And here when we write self.name equal name, it saves the data in the object's memory. Now let's discuss about some common questions. For example, what is a constructor? Again, it's a method called automatically when an object is created. Now you can ask, is dash dash init dash dash the only constructor in Python? The answer is yes, it's the default constructor used to initialize data. Then another question is, can we have a class without init? Yes, but then you must set data manually, as like this one. Then the next question is, can dash dash init dash dash have default values? The answer is yes. So let's see an example. For example, let me comment this. Now create another class called person, then def dash dash init, and there we expect parameter like name, but default value, for example, unknown. So if we do not provide a value while creating an object, then it should use unknown as a default name. And let's say we have another parameter called age, and here we can give a default value 0. So while creating an object, if we don't pass the age, it will consider the age as 0. Then we can say self dot name equal name, then self dot age equal age. Now let's create an object called p1 equal person, and as you can see, though we are not passing name and age, it is not showing errors because we have some default values. Even we don't pass any value or attribute, these values will be used as default value. Then everything is same as we have learned earlier. For example, you can define a function called show_info, and you can just print self.name is then self.age. Okay, then you can call p1.showInfo. If you run the code, you'll see it prints unknown is 0. But if you give the parameters, for example, Naruto, then age is 25, and run the code, you'll see it prints Naruto is 25. Now instead of unknown, we use Naruto because we are passing that, and instead of 0, we use 25 because for age we are passing 25. So we don't have to use the default value. Now you can pass a single parameter value as well. So if you just pass the name and run the code, you'll see it uses Naruto in the place of name. So Naruto is, then for age it uses the default value as we are not passing. Okay, but if I remove this and write here 25, it will throw error because we are not following the order. In the constructor, name is at first, so to give the age, first we have to give the name. Okay, so we have to give the name, means a string. Okay, it will work. But as you can see, the age is the second parameter. You just cannot ignore the first parameter and just pass the second parameter. If you try to run, it will become 25 is 0, so it will cause some error. So you have to follow the order. You can just ignore the later attributes. So for example, if you just pass Naruto, it will take the default value for other attributes which come later. If you want to use age, then you must put age first here. Okay, then again you have to follow the order. Now you have to give the age first, then you can give the name. If you run the code, you'll see it works fine. Naruto is 25. Now you can ignore giving name, and if you run the code, you'll see it prints unknown is 25. Okay, so that's all for this video. Before finishing this video, I want to give you an practice assignment. So create a class book, have a constructor that takes title, author and price, and add a method show details. Okay, and that method will just print all the data, for example title, author and price. So in our previous practice sessions I have gave all the solutions, but now as you understand classes, objects, constructor in more in depth, that's why I'm not gonna give you the solution of this practice example. I expect you to solve this on your own. So that's all for this video. See you in the next one. Hey learners, now let's dive into class methods, the functions you create inside a class to make your object useful. They can print info, calculate values, or do any task. So let's understand everything about methods in Python classes with real-life examples. So in terms of OOPS or object-oriented programming, what is a method in Python? So a method is a function inside a class. It's used to perform actions using the data stored in an object. A method always takes self as the first parameter, which refers to the object that called the method. For example, we have a class called student, and here we have a constructor, so def -- init. Then we expect a name and age, and in the constructor we can say self.name equal name, then self.age equal age. Then I can write def greet, and here I can print hi, I am self.name and I am self.age years old. Now we can create objects with that class. So I can write here s1 equal student. Let's say the student name is Gojo, age is 16. Now after that, let's call the method. So s1.greet. Now here greet is a method. So when I run the code, you'll see it prints hi, I am Gojo and I am 16 years old. Now this greet method and this self helps it access the data of the object that called it. Now in this greet method we just have this self parameter, means one parameter. Now let's take another example where we take more parameters in a method. So let me comment this and create a class called calculator. Here let's write def add. First of all, we have the self parameter, then we can have more parameters. As you can see, it's not a constructor, it's just a normal method inside a class. Then I can have a and b, and here we can just return a plus b. Okay, now I can write here c equal calculator. Now to create this c object, we don't have to pass anything because there is no constructor. That is not necessary. We can just create an object with just using that calculator class. Now here we can write the print statement and just write c.add to call the add method and just pass 10 and 5. Now if I run the code, you'll see it prints 15. So even though we pass only two numbers 10 and 5, so we don't have to pass a self, because Python automatically sends the object as the first argument self. We just have to pass the later parameters which comes after the self parameter. This is why all methods must include self first. So this self parameter should be at first. You can't just put other parameters before self. That's not allowed. Okay? You must put self first as parameter inside the class methods. Now let me comment this as well. And let's see another example method using objects own data. For example, we have a class called circle, and here we write def underscore underscore init underscore underscore. Then after self we want another parameter called radius, and in this constructor we can say that self dot radius equal radius. Now let's create a function to calculate the area of the circle. So def area, and we just want to return 3.1416 into self dot radius into self dot radius. So did you notice the difference here? We don't have radius as parameter in this function, but we have that in the constructor function. If you have any parameter in the constructor function, you can use that parameter value in every object with the help of this self. So with this self we can access the radius of each object, the value what is passed while creating that object in this radius parameter. Okay, so here I can write c1 equal then circle, and we must provide the radius. And here if I write the print statement and just write c1 dot area, call the function and just run the code, you'll see it prints the area of the circle. So this area doesn't need extra input because radius is already stored in the object. So while we create the object c1, we pass 7 in the radius. So we say that self.radius equal that 7 means the passed radius. Then with the help of self we can use the radius value in other methods as well, because we did this step in our constructor. So this is the real power of object-oriented programming. So now I think you understood better why do we use the self. It refers to the object calling the method, which is this one. Now what if you say that if I forgot to write the self, it will just throw error. You'll get a type error. Python expects it. If you run the code, you'll see it's a type error. Circle.area takes 0 positional arguments, but 1 was given. So you must give self parameter here because Python expects this. It's a must thing. Now you can ask, can methods call another methods? Yes, using self and then dot method name inside another method, we can use method inside a method. And let's see an example, a method calling another method. So let me comment this. Again, let's create a class called student. Now this time we have this constructor. We expect a name and marks. Then we write self dot name equal name. Then we write self dot marks equal marks. And let's write def grade. And in this method we can check if self dot marks is greater than or equal to 80, then we want to return string a plus. After that we write an elif statement. There we check if self dot marks greater or equal to 60, then we want to return just a. Now let's have the else part, and here we just want to return needs improvement. Okay, now it is a function or method. Now let's call this from another method. So let's define another method. So def show underscore result, And in this method, let's write print, then string formatting, and here we can write self dot name and grade is colon. Then we can call this method grade. So to call this method, we can just write here self to indicate the method for the current object. So we write the self, and here we just call the grade method. So as you can see, we are calling a method of class from another method. So now let's create an object. So s1 equal student name, let's say Nobara, and marks is 85. And here I can write s1 dot show result. Now if I call this method show result, it will try to print Nobara's grade is, then it will automatically call the grade method here, and as Nobara's grade is 85, it will return A plus. So the ultimate output would be Nobara's grade is A plus. Okay, but if you give here 65 and run the code, you will see it prints Nobara's grade is A. So the key point here is, in a class, a method can call another method of that class. Now let's take a bit more complex example. So let me comment this, and let's say you are working for a bank system. So there, for a software, you create a class account. So in this account class, we have a constructor, obviously. Then here we expect a name for the account holder, then a balance. And here we can write self dot name equal name, then self dot balance equal balance. Now we want to create method that changes object data. So for that we write def another method, and let's call this deposit. So every account holder deposits money in their account. So let's see how to handle that situation. So we have here the self parameter, then we can have an amount the user want to deposit. So after we get the amount, by the way, as you can see, this amount is not in the constructor. We are passing this amount in the deposit function. So we can't access amount by self.amount. Keep that in mind. That is not allowed. Okay? Because we are not sending amount in the constructor. So here, or an account holder deposits some amount, we want to update his balance. So here we can just write self.balance plus equal amount, means the new deposit amount. Okay? So as you can see, this method is changing balance, which is object data or attribute. Then we can create another method called show balance, and here we can print self dot name balance is self dot balance dollar. Now after that we can create an object called ec, and here we can just write the class name, and the account holder is, let's say, Satoru, and the balance is 1000 in the initial phase. Now here if I write the print statement and write ec dot show balance, and if I run the code, you will see it prints Satoru's balance is $1000. After that, let's say Satoru want to deposit some money, so ec dot deposit, and he wants to deposit $500. Now if I write here ec dot show balance again, okay, actually I have printed in the show balance method and I wrapped that inside a print statement, so there would be no print statement here because it's tried to print this print statement as well as the returned data, but this method does not returns anything, so that's why it prints none. So remove the print statement and just write account.showBalance. If I run the code, you'll see it prints Satoru's balance is $1000. Then after depositing $500, it says Satoru's balance is $1500. So deposit method updates the object's own balance. So that's how class methods work in Python. They make your objects powerful and smart. That's all for now. See you in the next one. Hello curious minds. Today we are diving into one of the core pillars of object-oriented programming, and that is abstraction. It's all about hiding complex things and only showing what's necessary. Let's understand what abstraction really means in Python, why it's useful, and how to implement it step by step. First of all, what is abstraction in object-oriented programming? Abstraction is the process of hiding internal implementation details and showing only essential features. A real-life example would be when you use a mobile phone, you just press buttons to call. You don't need to know how signals are transferred or what's happening inside the hardware. That's abstraction. Hide the complex parts, show only what matters to the user. Now, why abstraction? Why abstraction? It has some benefits. First of all, clean and simple interface. For example, users interact with only the necessary parts. Then it hides unnecessary complexity. So it helps you to hide internal logics and messy details. Then it improves security. So basically it prevents users from accidentally modifying sensitive logic. And lastly, it helps write easier to maintain code. You can change the inner code without affecting users of the class. Now there are some tools in Python for abstraction. So abstraction is implemented using abstract base classes and ABC module, which stands for abstract class base module. So let's see how we work with abstraction. First of all, we import ABC and abstract method. For that we write from ABC import ABC and abstract method. So after importing these, we write a class, for example animal. Inside parentheses let's write ABC, then at the rate abstract method, and let's create a method here, def make underscore sound, and just write here pass to say that do nothing. Now this ABC is a built-in base class for abstraction. So it's built inside Python. When you installed Python, this base class got installed. So again, ABC is a built-in base class for abstraction. And this at the rate abstract method means any class that inherits from animal must define the make sound method. Now the term inheritance is another topic of object-oriented programming. We'll cover that, but let's first understand how we work with abstract methods. So as this animal class, we can inherit the attributes and the methods of this class inside another class. So it is like you are a child and you are getting the properties of your parents. For example, we have a class called dog. Look carefully, it's not an object, it's a class. And we can give here animal. And if I hover on the yellow squiggly line, it says class dog must implement all abstract methods. Because we are defining, as this animal class has this abstract method, we must define that abstract method inside the child class as well. So here I can write def make underscore sound, and I can write print woof. Okay, now again we can create another class called cat, and we can give here animal. Now again, if I hover on this squiggly line, it says class cat must implement all abstract methods, because we are inheriting attributes and methods from animal, and this animal class holds an abstract method. So as abstract method is there, and as we are inheriting attributes and methods from animal, we have to write that methods, means the abstract methods, in the cat class as well. We have to write the make sound method again here. So make sound, and here just write print meow. Okay, now let's create some objects. So if I write here d equal and let's use the dog class. After using dog class, we can write d dot make sound. Now if I run the code, it throws error because we haven't used the colon here. Okay, now again if I run the code, it prints off because this dog class has this make sound method, and which tells to print off. We can have another object called c equal, then let's use the cat class and we can just write c dot make sound. Now if I run the code, it will print meow. So here both the dog class and cat class inherit from animal. They are forced to implement make sound method, otherwise this is just gonna throw error. For example, like this cat class, if you create another class called bird which also inherits from animal class, and if you don't write the make sound method which is there as an abstract method, if you don't write that and just do nothing here, or just write another methods and try to create an object using the bird class, so b equal bird, and if you try to run the code, it will throw error saying can't instantiate abstract class bird without implementation for abstract method make sound. So you have to write the abstract method which is defined in this class because you are inheriting from this class. Now let's see a real world example, and let's first import abc and abstract method, and let's try to create a payment system. So first of all, we have a class called payment processor. Inside this class we pass abc which we imported, and in this class we're gonna have an abstract method. Let's define that method. The method name is pay, and we expect the amount parameter, and let's tell this to do nothing. So this pass is just null operation. After that, let's create a class called debit card payment, and this inherits from the payment processor, so payment processor class. Now as soon as I write the payment processor class, Python understand that this class should inherit values, means attributes and methods from this class. So as this class has an abstract method, Python immediately tell us to define that abstract method in this class as well, otherwise it will throw error. So we write def pay, then we have to have those two parameters as well, self and amount, and here we can just write print paying amount dollar via debit card. After that, let's define another class called credit card payment, and here as well we want that it should inherit from payment processor class, so we have to write that abstract method here as well. So we write def pay amount, and here let me copy this print statement and paste that here, and we say here paying amount via credit card. Now let's create a function outside of classes. This function is not inside any classes, so let's write def make underscore payment, and here we take parameter, for example payment underscore method, then the amount as well. Okay, and here we can write payment method dot pay, and we pass amount. Okay, so this function is not inside any class, keep that in mind. So we have these three classes. So first of all, we have this payment processor class which has this pay method which is an abstract method, so we have to define that method inside the child classes which are gonna inherit these methods from this class which is payment processor class. So we define the pay method here and here as well, and we have this global function. Now we can create some objects with those classes. So first of all, let's create an object called p1 equal debit card payment, then we have p2 equal credit card payment. Okay, and here we can just write make payment, we can call this function actually, and here we can pass p1, means the object created using this class. So we are passing p1 for the parameter payment method, and the amount is 500. Then again, let's call this function make payment. Now this time let's pass P2 object, which is created from this credit card payment class. So let's pass P2 as the value for this payment method. Then amount would be 800. Now if I run the code, you'll see it prints paying $500 via debit card, and again it prints paying $800 via credit card. So this payment processor is abstract and can't be used directly. All child classes, means these classes, must define the pay method, means this abstract method. As you can see, we defined this pay method in all the child classes. The function make payment works with any object that follows the abstract class. Now it's Q&A time. So some beginner doubts are, they ask that why not just use normal classes? So the answer is abstraction forces structure and hides unnecessary details. Then again, you can ask, can we have both abstract and normal methods in a class? Yes, abstract classes can have both. Here we can have abstract methods and we can have other methods as well. So we can define other methods without making them abstract method like this. So we can have both. Then you can ask, can we create objects of an abstract class? No, the answer is no. Abstract classes are only meant to be inherited. So when we create an abstract class, we just pass them in child classes to inherit attributes and methods. We can't create object with them. So if I try to create an object P3 equal, and the class name is payment processor, if I try to use that class to create an object, this will throw error. So for example, if I write here make payment and an amount, for example 200, and try to run the code, you'll see it throws error. It says can't instantiate abstract class payment processor without implementation of abstract method. So we can't create object with abstract classes. We just use abstract classes in the child class to inherit. And you can ask, is abstraction useful in small projects? The answer would be not always necessary, but it teaches good coding practices. Okay, so that's all we have in the abstraction part. Let me run the code to remove the error. I hope you understood all the topics discussed in the video. In the next video, we're going to discuss about encapsulation, which is another important topic in object-oriented programming. Welcome back. In the last video, we learned about abstraction, hiding complexity. Today, we'll cover encapsulation, another essential pillar of object-oriented programming. This concept helps you protect your data and control how it's accessed or modified. So let's dive in. Now, the first question is, what is encapsulation? Encapsulation means wrapping the data, means variables, and the code methods that works on the data into a single unit, usually a class, and restricting direct access to some of the object's components. Let's have a real-life example. Think of a bank ATM. So we have an ATM. There you press buttons, but you can't access the internal wires or money box that is protected. So the buttons are the interface of the ATM. The system controls how much you can withdraw based on your balance. That's encapsulation. You interact with what you are allowed to. The rest is safely hidden. So in Python, when we talk about encapsulation, Python uses convention-based visibility. So there are three types of visibility. First, we have public, the default one, and the public data or variables can be accessed from anywhere. Then we have underscore protected. So the type is protected, but we write with underscore. That's why I'm calling underscore protected. So it shouldn't be accessed outside by convention. You can access it. It is a developer convention. Then there is private type, which we write by underscore underscore. So double underscore private. So name mangling makes it hard to access directly. Now let's take some examples. First of all, let's think we have a class called student, and there we have this constructor dash init, and we expect another parameter which is name, and here we can say that self.name equal name. Now if you look closely, when we say self.name, this name does not have any underscore before it, not single underscore or not even double underscore. So as we don't have any underscore before this property, that's why it is public, means it is by default public. So this can be accessed from anywhere. So for example, if I create an object s equal, and if I use the student class, and let's pass here Gojo, then if I try to print the name of the student, so s dot name. Okay, so here as name is public, we can access that without any issue, so it is okay. If I run the code, you'll see it prints Gojo. So here name is public and anyone can access or change it directly. But if I add here one underscore, then as you can see, it warns us with yellow squiggly lines. So this becomes protected. So the name variable or name data is now protected. Now you can access as.name, so it is allowed but discouraged outside the class. So developers are discouraged using this approach outside the class. It's just a convention. If I run the code, you will see that it says allowed but discouraged outside the class. Okay, so we are seeing this error because we haven't added the underscore here. Now if I run the code, you will see it prints Gojo, but still you will see that the statement has some light yellow squiggly lines. That means we are allowed to run this code, but it is not recommended or discouraged for the developers to use this approach. Okay, because Python treats this as protected. It's still accessible, but you are telling others to not access it directly. Now before name, if I give two underscores, then it becomes private. Now you can see the yellow squiggly lines is now more yellowish. So even if I add the second underscore here, means the two underscores, you'll see that this is showing more yellowish warning. This means Python will not allow us to do this. If I try to run this code, you will see it throws error. But there is a concept called name mangling. So name mangling, by which we can access this. So let's see what is name mangling. Let me delete this comment. So for name mangling, we write the object name. So here the object name is s. Okay, then we write underscore class. So the class name here is student. So we give the underscore sign, then we write the class name of the object student. Then we give that private data or private variable. So underscore underscore name. Now if I run the code, you see that it prints Gojo. So only name mangling allow us to access private data. Otherwise you can't access private data or private variables. So name mangling allows access. And what is name mangling? We write the object. So object name, for example, in this case s. If you give here s1, then s1 would be the object name. So object, then we give a dot, then we give underscore, then the class name. Class name, in this case the class name is student. Then we give two more underscore and we give the variable name. In this case the variable name is name. So var name. So if we consider with respect to this example, then finally we get s dot underscore student underscore underscore name. Now let me comment this and show you another example. So we can access them with controlled access using getters and setters method. So let's see how to do that. First of all, let's assume we have a class called bank account. Then we have this constructor and we have this balance parameter, and here we have a private data. So the balance is private, so we write self dot underscore underscore balance equal balance, this one. Okay, after writing the constructor, let's write another function. So def deposit, and we accept the amount parameter here, and we check if amount is greater than 0, then we want to do self dot underscore underscore balance plus equal the deposit amount. Then let's say we have another method, so def withdraw, and there also we will have this amount parameter. So we want to know how much amount the user want to withdraw, and inside this method we want to check if 0 less than amount, then less equal self dot underscore underscore balance. If that is the case, so we are checking user should try to withdraw the amount which is greater than 0, and that should be less than his balance. So he can't withdraw any amount that is not present in his account. Then if that is the case, we do self dot underscore underscore balance minus equal amount, and we reduce the amount from his account because he is withdrawing that. Else we just print that invalid withdrawal. Now lastly we need another method, so def get balance, and here we just return self dot underscore underscore balance. So our bank account class is done. Now let's create an object. So the object name would be account, and we use the bank account class, and for the balance initially we give $1000. Then we can do some deposits, as you can see. So we write here account dot deposit $500. Then we can do some withdraw actions. So account dot withdraw $200. Then we write the print statement, and here we write account dot get balance. Now if I run the code, you'll see it prints 1300. So again, here as we have this underscore underscore balance, this means this data is private, and this deposit and withdraw methods provide controlled access. You can't access underscore underscore balance directly, so this protects the data. As you can see, we are getting the balance using this method, which is get balance. But if you just try to print account dot underscore underscore balance, this will throw an error. As you can see, it throws error. Instead of accessing directly, we access that using the getter function here, and we change that using these setter functions. So as you can see, we are setting some updated data there. So we get some controlled access using getters and setters method. Now here some common beginner questions. First of all, they ask, can I still access private variables? Yes, you can access using this name mangling, like this example. As you can see here, the example. Then you can ask that why use encapsulation in small scripts? So the answer would be it builds good habits and prevents bugs as your app grows. Now you can ask, is Python strict about private data? Not really. It's convention based, not enforced like Java. So as you can see, still we can access with name mangling. Now you can ask that should I always use get and set methods? The answer would be only when you need control or validation over how data is used, then you can use these methods. Okay, so it's practice time. So let me comment this code. So this whole code. So the task here is create a class called employee, which has a private attribute, means variable, underscore underscore salary, and add some methods to get and set the salary. So method to add to get and set the salary. Keep in mind that when setting salary, don't allow negative values. Now pause the video and try to implement this on your own. Have you done that? If yes, then it is amazing. If you couldn't do that, don't worry, we're gonna do that together. First, let me run this code to remove the error. Now let's complete this task. First of all, let's create this class called employee, and there we have this constructor, and we allow name and salary. You can omit name as we don't said before to add name, but let's have a name. Then in the constructor we can say self.name, so it is a public attribute. So self.name equal name. Then we write self.__ salary equal salary. So this is private. Now let's create another method. So def get salary. So this is the getter, and here we just return self.__ salary. Okay, as we can't access object.__ salary, we use this getter. Now let's define a setter function as well. So def set salary, and here we have to check that the amount should not be negative. So here we have this amount parameter. Then inside the method we say if amount is greater than 0. If that is the case, then we say self.__ salary equal the amount. Else we write print invalid salary. Okay, so the class is done. Let me minimize the terminal a little bit. Now let's create some object. So the object name is E, for example. Then let's use that employee class, and the employee name is, let's say, Satoru, and his salary is 12,000. Now here we can just write the print statement and e.getSalary. So now if I run the code, you'll see it gives the salary of Satoru. So we used the getter function. Now let's update his salary using the setter. So we write e.setSalary 35,000. Then again we write the print statement and we write e.getSalary to get the updated salary. If I run the code, you can see first it prints 12,000 here, but when we update the salary, it prints 35,000. Now if you do e.setSalary and if you give here -1,000, as we are doing this validation, which is amount should be greater than 0, if I run the code, you will see that invalid salary, which is this one. So great job understanding encapsulation. It's your tool to make sure the right data is accessed the right way. In the next video, we'll tackle polymorphism, how a single function can work in different ways. So stay tuned and subscribe for more beginner-friendly Python videos. So let's explore polymorphism, an OOP concept that might sound complex but is actually super intuitive. So polymorphism allows the same function or operator to behave differently based on the object. So let's break this down with simple examples. So first of all, what is polymorphism? So the word polymorphism comes from Greek. Poly means many and morph means forms. So ultimately polymorphism means many forms. In simple terms, one name, many forms. In Python, polymorphism lets you use the same interface, for example function, method or operator, with different data types or classes, and it behaves according to the data it's working with. So first of all, let's see example of polymorphism in built-in functions. So built-in functions. If you can remember, we used a function called len. For example, if I write here the print statement and call the len function, and inside a len function, if I provide the string Python, and if I run the code, you'll see it prints 6. Okay, but if I provide different data type in the len function, let's see what happens. So if I write the print statement again and call the len function, and here let's say we pass a list of some numbers, for example 1, 2 and 3. Now if I run the code, it prints 3. So the length of the list is 3. Let's again write the print statement, call the len function, and this time let's pass some key value pairs. So for example, with the key is A, the value is 1, then we can give a comma, key is B, value is 2. If I run the code, you'll see it prints 2. So it is printing there is 2 key value pairs. Here len is the same function, but it behaves differently depending on what's measuring. This is polymorphism in action. As you can see, while we pass a string, the len function gives number of characters. If we give a list, it gives the number of items in the list. If we give key value pairs, it gives number of key value pairs. So it is behaving differently based on what it is measuring. So we saw polymorphism with built-in functions. Now let's see polymorphism with operators. So if I write here the print statement, here if I write 5 plus 10 and run the code, it prints 15. So here the plus operator is doing integer addition. But if I write the print statement again, and here if I write a string py, then if I give a plus operator, then again if I give a string, then thon, and run the code, you'll see it prints Python. So here Python is doing string concatenation. Again, if I write the print statement, let's say we have a list, the values are 1 and 2, then we give the plus operator, and we have another list with the value 3 and 4, and if I run the code, you'll see it merges 2 lists into 1. So the plus operator in this statement merging lists. So the operator is same, the plus operator, but the behavior is different based on type. First of all, it adds numbers, then it joins strings, then in the third example it merges lists. So enough of this. Now let's see polymorphism in classes, and that is with methods. Now let's say we have a class called dog, and here we can write a method called speak, and we just return a string woof. Okay, then let's create another class called cat, and here we have another method, and here we have the same method speak, which returns the string meow. Okay, now let's have a variable called animals, which will be a list, and in that list we will have 2 objects using these 2 classes. So the first item of the list would be created based on dog class. We don't have to pass anything because there is no constructor and extra parameter. And the second object of the animals list would be created based on the cat class. Okay, now inside this animals list we have 2 objects, so we can loop through this list. So we can write the for keyword, then animal in animals, and we write the print statement, and we write animal dot speak. Okay, now if I run the code, you'll see first it prints woof, then it prints meow. So here each class has its own version of speak method. As you can see, we use the same method name, but the behavior depends on the object type. So the first object type is dog and the second object type is cat. So the method name is same, but the behavior depends on the object type. So this makes code flexible and easy to maintain. Now let me comment this code. Now let's see polymorphism using inheritance. Now we haven't covered inheritance yet vastly. We saw a little bit example in our previous videos. We will have a dedicated video on inheritance in the next video later. But let's see how polymorphism works using inheritance. We call this method overriding. So in inheritance we have parent classes and child classes. Let's say we have a class called animal and we create a method makeSound which returns this string which is some generic sound. Then let's create another class bird which inherits data from the animal class, and here we write the makeSound method again and we return a string chirp. Now we can create another class cow which also inherits data and methods from the parent animal class. So let's define that makeSound method here as well and we return a string moo. Is it sounded like a cow? I don't think so. Okay, let's move forward. Now here we can have a list. So animals list which will contain 3 objects. First object we're gonna create with the parent class, so animal, and the second element of the list which will be a second object, we're gonna create that using the bird class. Then the third one will be created using the cow class. Then here we can write for a in animals print a dot makeSound. Now if I run the code, you'll see first it prints some generic sound, then it prints chirp, then it prints moo. All classes here have a makeSound method. These subclasses or child classes override the parent method to give specific sounds. So when we inherit data and methods from this parent class, we get this method here as well. For example, if I remove this and just write here pass and run the code, you'll see even the bird object, this second one, also prints some generic sound. But as you can see, we don't have that makeSound method in the bird class, but it is inheriting that method from animal. That's why it is printing the statement from the animal class. But if we override that method in the bird class, then this method will kind of replace this method. So if I run the code, you'll see it prints chirp. So here subclasses override the parent method to give specific sounds. This is a powerful use of polymorphism. Same method but different output. Now again, let me comment this code. Let's have some spaces and let's see polymorphism with functions and duck typing. Now here Python uses a concept called duck typing. If it walks like a duck and quacks like a duck, it's a duck. Let's think about, we have a class called book and there we have this method called display which prints reading a book. Then let's say we have another class video which has display method and there we write the print statement and let's say watching a video, and let's have a function outside the classes. It's a general function, you can say. So def show underscore media, and here we take a media parameter and in the function we say media dot display. Okay, now after defining the function we can call this a show media function, so show media, and inside here we can pass an object by creating with the book class. So we are creating the object with book class, and as soon as we create, we just pass that in the show media function. Okay, again let's call the show media function and pass another object created with the video class. Now if I run the code, you'll see the output reading a book then watching a video. So here we didn't care what the object is as long as it has the display method. We can call it. So this is duck typing based polymorphism, a feature that makes Python very flexible. Now let's see when and why to use polymorphism. So the first reason to use polymorphism would be code reusability. And here is a benefit. We can write common code that works on multiple types. Then the second reason would be flexibility. And the benefit is we can easily swap objects without changing the function logic. And the third reason would be maintainability. And the benefit would be add new types without modifying existing code. Now let me answer some beginner questions. So the first question would be, is polymorphism only for classes? And the answer would be no. Operators and built-in functions also show polymorphic behavior. And the second question would be, is method overriding necessary? Again, the answer would be no, but it's a common in inheritance-based polymorphism. The third question would be, can I use polymorphism without object-oriented programming? The answer would be yes. Functions like len, then plus operator, and the print statement are already polymorphic. Then another question can be, is duck typing the same as polymorphism? The answer would be, duck typing enables polymorphism in Python by checking behavior but not type. So we have practiced a lot about polymorphism. Now here is a practice task for you. So create two classes. So two classes, first one is car and second one is bike, and each with a method start. Then call them from a single function and show polymorphism. Now pause the video and try to implement this on your own. So have you done that? If yes, that's great. If you couldn't do that, let's implement that together. So first of all, we have a class called car, and here we have a function, our method start, and inside that method we just write the print statement which says car engine started. After writing the car class, we can define another class which is bike, and here we have this method start and it prints bike engine started. Now after writing the classes, we can write a general method. So def vehicle start, the method name, and in the parameter we take the vehicle, and inside that function we write vehicle dot start and we call this start method. After writing this function, we can call vehicle start method, and we can create an object with the car class and just pass that inside this vehicle parameter. So we can write here car, and again let's call that method vehicle start, and let's pass the object by creating with the bike class. Now if I run the code, you'll see first it prints car engine started, then it prints bike engine started. Okay, so that was the beauty of polymorphism. It lets your code be clean, flexible, and powerful. Up next, we are diving into one of the most important concepts of object-oriented programming, and that is inheritance. So see you in the next video. So let's learn about inheritance in Python, a powerful feature of object-oriented programming that helps you reuse code, reduce repetition, and build relationships between classes. Whether you're building games, apps, or web platforms, inheritance is essential. First of all, what is inheritance? Inheritance allows one class, called the child or derived class, to inherit properties or methods from another class, which we call parent or base class. Think of like this: a car is a vehicle, and then a dog is an animal. Car is a child or derived class, and this vehicle is parent or base class. In this example, dog is a child or derived class, and animal is parent or base class. So inheritance helps reduce code duplication and keeps things organized. So let's see basic syntax of inheritance. First of all, let's say we have a class called animal. There we have a method speak which prints animal speaks. Then we can have another class which is dog, and here animal class is the parent class or base class, and this dog is child class. So we want the properties and methods from the parent class to this child class. So we have to inherit from the animal class. So we give here animal. Then here we write pass to tell Python do null operation, means do nothing. In this class we are doing nothing, but the parent class has this method speak which prints animal speaks. Now here if I create an object D with the dog class which has no methods, but the parent class has this speak method, so we are inheriting that speak method inside this dog class. So in the D object we can call the speak method from the parent class. Okay, so if I run the code, you'll see it prints animal speaks, though we don't have that speak method in the dog class. We are inheriting that from animal parent class. After that we can create another class which is cat that also inherits from animal class, and here we have a method speak. So we are overriding that method from the parent class, but we haven't overridden that in the dog class, but we are overriding in the cat class, and this method just prints meow. Now if I create an object C with the cat class, then we can write c.speak. Now as we are overriding the speak method in the cat child class, this will print meow, but as we are not overriding speak class in the dog child class, so it will just inherit from the animal class. Okay, so if I run the code, you will see the dog class speak method which is inherited from the animal class prints animal speaks, but the cat class object which is C, when we call the speak method, it gets the speak method from the animal parent class, but we override that class by rewriting that here in the cat child class. Now we can add child specific methods. So in the dog, instead of pass, we can write another method called bark, and there we can write print statement. Let's say it makes woof sound while barking. Okay, now when we create an object with the dog class, we have the speak method from the parent class and this bark method which is specific to the child class. So we can just write d.bark. So now if I run the code, first you will see animal speaks, then woof, and then this c.speak runs which prints meow. And let's see another concept in inheritance, and that is constructor chaining. So let's say we have a class called person. There we have this special method constructor. After self parameter we have the name parameter as well, and here we say self dot name equal name. Now we have another class student, and a student would be a person, so we can inherit from the person class. So the person class would be the parent class, and here also we have this constructor, and we have name parameter, then a grade parameter. Now here we have a keyword called super. We can call that, then dot underscore underscore init underscore underscore name. I'll explain this a bit later. Then we can write here self dot grade equal grade. Now after writing these classes, let's create an object S with the student class, and let's provide name Alice, then grade is A. Let's write the print statement as dot name Then again the print statement s.grade. Now if I run the code, you'll see it prints Alice and then the grade A. Now when we write super, now when we call the super, we tell Python that call methods from the parent class, not this class. So we are calling super, saying that do not call the method init from this class but the parent class. So the parent class constructor actually. And the student adds new behavior grade while reusing the name logic. Now let's see the use case of is instance and is subclass. So here if I write the print statement and if I call the is instance method and if I pass this as object, then in the second parameter if I give here a student and if I run the code, you'll see it prints true. That means this as object is an instance of the student class. Now let's check if this as object is instance of person class or not. So again let's write the print statement. Let's write is instance. Let's pass the as object, and this time instead of student let's pass the person class. Now if I run the code, you'll see again it prints true. This as object is also instance of this person class. Then let's see the use case of is subclass function. If I write the print statement and let's check is subclass and let's pass the student class, which is the child class actually. Then we give the parent class. In this example the parent class is the person class. Now if I run the code, you'll see it prints true. That means student class is a subclass of this person class. So is instance method checks if an object is an instance of a class, and this is subclass method checks class relationships. Now let me answer some of your questions. First of all, why to use inheritance? Because it provides reusability, no need to write code for shared features. Then it provides readability, group related classes becomes together. Then it provides scalability, so we can add new child classes easily. Then it provides maintainability, which helps us update shared logic in one place. Now you can ask, can a child class access private attributes? The answer is no. Use protected or public ones. Then you can ask, can a class inherit from multiple classes? Yes. It will be covered in the next video. Then you can ask, is super method required? So this one, the answer would be only if you are using the parents constructor. Then you can ask, can child classes override any method? The answer is yes, including constructors and regular methods. Now let me comment this code and let me give you a task, and the task is create a class called vehicle with move method, then create child class car that overrides move method to print car is moving. So pause the video and try yourself to solve this. Have you done that? If yes, that's great. If not, let's solve that together. So first of all, we have a class called vehicle. There we have a method called move, which prints vehicle is moving. And let's say we have another class car, which inherits from the vehicle class. So the vehicle class is parent class, and there we override the move method. Let me have some spaces here. And while overwriting the move method, we just print car is moving. Okay. Now we can create an object v with the parent vehicle class. Then we can create another object with the car class. Now here we can write v.move, and again we can call the move method in the C object as well. Now if I run the code, you'll see first it prints vehicle is moving. Then while working with the car object, it says car is moving. So that's how inheritance works in Python, giving you the power to build smarter, reusable, and well-organized code. In the next video, we'll explore multiple inheritance and see how Python handles it. So don't miss it. In this video, we'll explore multiple inheritance in Python, a concept where a child class can inherit from more than one parent class. We'll learn how it works, why it's useful, and how Python handles conflicts with something called method resolution order. In short form, we call that MRO. Again, it stands for method resolution order. Now, before proceeding, the question arises, what is multiple inheritance? Multiple inheritance means a class can inherit attributes and methods from more than one parent class. This helps when you want a class to continue behaviors from multiple sources. Now, let's say we have a class called father, and there we have this method called skills, and we print there gardening and programming. Okay, then let's say we have another class mother, and we have that skills method here as well. And there we print cooking and painting. Okay, now we have another class, and let's call this child. I guess you can name this anything, but let's call this child. That makes more sense here. And here in this class we can inherit attributes and methods from both of the above classes. So we can inherit from father class and as well as the mother class. Okay, inside this child class we'll do a null operation, so we're gonna just write pass. This doesn't do anything actually, but we have the skills method in the father class and mother class as well. So far so good. Now we can create an object c equal child class. Okay, now let's write c dot skills and call this method, and let's run this code. Let's see what happens. If I run this, you'll see it prints gardening then programming. So what's happening here? So this child class inherits from this father class as well as the mother class. The method skills is present in both parents, but Python calls only father's version because of MRO, which we talked about a minute before. MRO means method resolution order, and that is left to right in order. So while we talk about inheritance list, the order is left to right, and method resolution order is exactly that. Now let's talk about what is happening behind the scenes with MRO. So Python looks for methods in the following order. So here we have these parent classes. So the top left parent is father here. Next parent is the right one, which is mother class. At first means it is in the left, the order is left to right. So it is giving priority to the father parent class. If you put mother parent class first and then you give father parent class and run the code, you'll see it will print the skills from mother class. Let me put father at the first again, run the code. As you can see, gardening and programming. Now you can see the order or the MRO by writing the print statement, and if you write child, which is this class, dot underscore underscore MRO underscore underscore, and if you run this code, you'll see we have this child which is left if we compare with father as well, and then between these two, this father class is at the left side, and at the right side we have this mother class. And if we have more parent class after mother, that would be on the right side. So ultimately the leftest one will get high priority. Now if you want to call both parent methods, you can do that as well. For that, instead of pass in the child class, you can write that skills method again here. In that method, you can just write father dot skills and pass self, and after that if you write mother dot skills and if you pass self here as well. Now when you call c dot skills after creating the c object with the child class, and if you run the code, you'll see it prints both gardening programming from the father class, then it prints cooking and painting from the mother class as well. So here we explicitly call both parent methods using their class names. As you can see, they are class names. This lets us combine behavior when there's a method name conflict. Now I hope you understood this part, so let me comment this. Let's have some spaces before we move forward. And here, let's use the super method in multiple inheritance. Okay, so Python's super works differently in multiple inheritance. It uses the MRO chain, not just the direct parent. So let's see an example. For example, we have a class called A, and there we have a method show, and inside the method we just print string A and comma and equal empty string which holds just a space. Then here we write super dot show. Now let's create another class called B. There we have that method show as well, and here we have a print which prints B and the end which has this space. And let's say we have another class C which inherits from A and B, considering them as parent, and it holds the show method, and here we tell to print C and end would be again a space. Now in the C class we call the super dot show method. Now let's create an object C, a small c actually, with the capital C class, and here we can write c dot show. Now if I run the code, you'll see it prints C A B. So what is happening here? So here super works through the MRO. First at the left we have the C class, so it executes this show method and prints C, and here as you can see, so it adds a space. Then we say super dot show, and here after the left test we have A at the second left, so it is printing A. Okay, and at the very right we have this B class as parent class, so it is printing B at the very last, as you can see. So Python ensures each parent's show runs once in MRO chain. Now here are some potential conflicts and good practices. So problem 1 would be method name conflict, and the solution for that would be to use unique names or override in child class. Okay, so use method names as unique names, or if you want to use the same name, then just override that in the child class to solve the potential conflicts. And another problem arises, that is confusing MRO chain. So to solve that, use the super carefully and print underscore underscore MRO underscore underscore, this one, to see the MRO order, so which is at the leftest, then the second left position belongs to which class, then which class in the right position. So you can check that by running this one. Then another potential issue could be hard to maintain hierarchies. So to solve that, refer composition over inheritance if things get too complex. Now you can ask, can a child inherit more than 2 classes? As we saw, yes, you can inherit from as many as needed. It doesn't matter. Then you can ask, what if both parents have the same method? The answer would be Python follows MRO order, which is left to right. And the third question can be, can we force both methods to run? Yes, by calling them explicitly, what we did here. Then the last question can be, does super always mean parent? The answer is no. It follows the MRO, not just the direct parent. So this example is done. Let me comment this. Now let me give you a task. Create classes with the name writer and speaker with having show method, and create a person class that inherits both and prints both behavior. Okay, so pause the video and try to solve this by your own. So have you done that? If yes, then it is great. If you couldn't do that, let's solve this now together. So first of all, let's say we have a class called writer. I'll go first in this example because we saw so many things, so I don't want to make the video any more longer, so I'll go faster. So here we will have this show method which prints writes article. Then we have a class called speaker. There we have this show method that also prints, and that prints speaks at events. Then let's have class person, and we want to inherit from writer and as well as speaker. We will have that show method, and as we want that both show method should be executed, that's why we have to do that explicitly. So here we are gonna write writer dot show and just pass self, then speaker dot show and pass self. Then we write p to create an object with the name p, and we use the person class. Then let's call p.show. Now if I run the code, you'll see it prints writes article, then it prints speak at events. So I hope you were able to solve this. This was quite easy actually. So that was multiple inheritance. It's powerful but must be used wisely to avoid confusion. In the next video, we'll learn about multi-level inheritance, how classes inherit from other classes in a chain. So see you there. In this video, we are diving into multi-level inheritance in Python, a situation where a class inherits from a child class, which itself inherits from another class. Think of it as a family chain. For example, grandparent to parent to child. Okay, so let's understand how it works and how Python handles this layered hierarchy. First of all, what is multi-level inheritance? So in multi-level inheritance, think about a scenario. We have a class A, which is base class. Then we have class B that inherits from class A. Then we have class C, which inherits from class B. Okay, now if we convert this into a code, this will look like similar to this one. So class A, and it is the base class, then class B, which inherits from A, it is the intermediate class. Then we have class C, which inherits from class B, and it is the final child. Okay, so I hope you understood the concept. Let me comment this out and let's see a more realistic example. Let's say we have a class called grandparent or grandfather actually. There we have a method called property, and that prints land and house. Then let's say we have another class that is father, which inherits from grandfather, and we have a method called car, and we just print owns a car. Then let's have a class called son, which inherits from the father class. There we have this method bike, and this prints owns a bike. Okay, now for creating these classes, we can create an object with the son class. Now as we are inheriting from father class in the son class, so we get this method, and as we are inheriting property method from grandfather method in this class, we also get that in this class. So here we can just write a dot property, which is there in the grandfather class. So ultimately it comes to this son class through the father class actually. Then we can call the car method, and it comes from this father class, and son has its own method, and that is bike. Okay, now if I run the code, you will see son owns land and house, owns a car, and owns a bike. So land and house he got from his grandfather through his father, and he got car which was owned by his father, which he got from his father directly. Then he himself owns a bike, means this bike method in this example. So ultimately son inherits from father, who inherits from grandfather. So son has now access to everything from both father and grandfather. This is called multi-level inheritance, which is 3 levels deep. So if you ask what happens behind the scenes, the answer would be when you create an object of the child class, as we are doing this here, Python searches the method in the child class son. Okay, if not found, it looks in the parent class, which is father. If still not found, it moves to the grandfather class. So this is automatic chaining based on MRO, method resolution order, which we saw in our last video. Again, if you write the print statement, and then if you write son dot underscore underscore MRO underscore underscore, and if you run the code, you will see that son is the leftist position. So first it will search for property method in the son class. When it would not found that here, it will go to the father class. When Python does not find that here also, it goes to the grandfather class and sees that the property method is available, and it executes that. Okay, and when you call the car method, first it goes to the son class. As you can see, son class is at the first position, so it does not find the car method here, so it goes to the father class and finds the car method, so it executes the car method. But when you call the bike method, Python finds the bike method in the son class itself, so it runs that. So as you can see, first it tries to find from the son class, then it tries to find from the father class, then it tries to find from the grandfather class. So it is a chain in order left to right. Now I hope you understood this example, so let me comment this out and give you another example. Before that, let me run this file so output becomes empty. And this example is about using constructors in multi-level inheritance. So let's see how the dash dash init dash dash means the constructor method works in each class. For example, we have a class called A, and there we have this method which is dash dash init dash dash, actually the constructor, and in the constructor we just print init A. Now let's say we have another class B which inherits from A, and there we have the constructor. In the constructor we call the super and call the parent constructor. Then let's write the print statement, and here we want to print init B. Now let's say we have another class C which inherits from the class B, and there we have this constructor again, and here also we call the super, and we want to call the constructor of the parent class. So that's why we are using super, and after calling we want to print init C. Now what I can do is I can write here C equal, and I can use the capital C class. Now if I run the code, you'll see it prints init A, then init B, then init C. So though we are creating the object using the class C, but in the constructor of class C we are telling first run the constructor of class B before printing init C, and inside that class B we are telling that first run the constructor of the parent class, which is the class A, before printing init B. So it goes to the class A and first prints init A, which means it executes this line. Then it prints init B, which means Python executes this line. Then it prints init C. So here super is used to call the parent class constructor. Each class builds on top of the previous one. Now if you ask why use multi-level inheritance, I'll tell some use cases. First of all, extending behavior over time. For example, software versions or updates. And another use case would be representing generations or stages. For example, family or class hierarchy. Then another use case would be reusability. So common logic in base class. So this one you can say. Now there are some common questions beginners ask actually. So first of all, they ask, can we skip a level? The answer would be not directly, because inheritance is stepwise. Then another question would be, can we use super in each class? Yes, to call the parent's constructor or method, we use super in each class. As you can see, to call the constructor of parent class, we are using super, which runs this constructor. Now you can ask, what if two classes have same method? So the answer would be MRO still applies. So the order is left to right. Python searches from bottom to top. First it searches the method in the final child class, then in the intermediate class, then in the top parent class. Now you can ask, how deep can this go? So the answer would be as many levels as needed. Though deep chains are discouraged for readability. So you can create as many as this kind of chaining classes, but do not create so many that it becomes harder in case of readability. So I hope you understood this code. Now here is a task for you. The task is create a device class with method features, then inherit a phone from it and add a call method, then inherit smartphone from phone and add browse method, then call all the methods from the smartphone object. Now pause the recording and try to solve this on your own. Have you done that? If yes, it is great. If not, let's solve this together. So I'll go faster this time because we have understood many things. Otherwise, if I keep, then this video will become so much longer. So I'll go faster this time. First of all, we have a class device which has a method features, and we print there a string which is basic device features. Okay, then we have a class phone and that inherits from device, and here we have a method called call and we print this can make calls. Then let's say we have another class smartphone which inherits from the phone class, and we have a method browse and we print in that method can browse internet. Now let's create an object sp with the smartphone class. So the smartphone inherits from phone class and phone class inherits from device class. So ultimately this smartphone class will get this method and this method as well. So here we can call sp.features method from the device class. Then we can call sp.call method from the phone class, and ultimately we can call the browse class from the smartphone class itself. Now if I run the code, you'll see it prints basic device features from here, then it prints this can make calls from the phone class, then it prints can browse internet from the smartphone class itself. So that wraps up multi-level inheritance. It's an easy way to extend functionality step by step. In the next video, we'll explore hybrid and hierarchical inheritance, where things get more interesting with multiple paths. So see you there. In this video, we'll explore two more inheritance types, and those are hybrid inheritance and hierarchical inheritance. These concepts are important when your application grows and you want to organize your classes efficiently. Let's break it down with beginner-friendly examples and visuals. First of all, what is hierarchical inheritance? In hierarchical inheritance, multiple child classes inherit from a single parent class. So for example, we have a class called parent. There we do a null operation by writing pass. So let's say we have another class with the name child1, which inherits from parent class. There we also write pass. We have this spelling mistake here. Okay, after that, let's say we have another class which is child2, which also inherits from the parent class, and in the class we just write pass. So as you can see, we have two child classes in this code. Both are inheriting from the single parent class, this one. So all child classes get access to the parent's attributes and methods. I hope you understood the concept. So let's have an example. For example, we have a class called animal. There we have a method def speak, and there we print animals make sounds. Now let's create another class with the name dog, which inherits from the animal class, and there we have a method called bark, and we print dog barks. Again, let's say we have another class cat, which also inherits from the class animal. There we have a method called meow, and we print cat meows. Now let's create an object with the name D, and let's use the dog class. Let's create another object C with the cat class. Both are inheriting from the animal parent class, as you can see. So the speak method is there now in the dog class as well as in the cat class. So we can call d.speak. Then in the dog class with the speak method, we have his own method which is bark. We can call that as well. So d.bark. Now if I run the code, you'll see it prints animals make sounds. Then it prints dog barks. So this one and this one. Okay. Now we created the C object with the cat class. So we can write here c.speak. Then again c.meow. Now if I run the code again, you can see after the D objects print statements, it prints C objects print statements. So as cat also inherits this method from animal class, it prints animals make sounds, then it prints cat meows from its own method. Now I hope you understood hierarchical inheritance. So let me comment this code. Okay. So now you can ask, what is hybrid inheritance? So hybrid inheritance is a combination of two or more types of inheritance, like single, multi-level, or multiple inheritance. This is common in real-world projects. So let's see an example. Let's have some spaces here, and we are seeing hybrid inheritance in action. So we need to combine two types of inheritance at least. So let's combine multi-level plus hierarchical inheritance. Let's say we have a class vehicle. There we have a method engine, and we print has engine. Then let's say we have another class car, which inherits from vehicle. There we have a method wheels, and there we print car has 4 wheels. And again we have another class bike, which also inherits from the vehicle class. There we have a method wheels, and there we print bike has 2 wheels. Let's say we have another class which is electric car, and this inherits from car. Okay, so these two inheriting from vehicle, and electric car is inheriting from this car class. And here we have a method called battery, and here we just print battery powered. Okay, now let me explain this a bit to you. So here this vehicle is the base class, and car and bike is inheriting from vehicle. So here hierarchical inheritance is happening, but this electric car is inheriting from this car class, which is inheriting from vehicle class. So this is multi-level inheritance. So we are combining multi-level and hierarchical inheritance. So this is ultimately a hybrid inheritance structure. Now in our previous videos we talked about the MRO, or the method resolution order. So let's understand method resolution order in this case. So even in hybrid structures, Python handles method resolution cleanly using MRO. To check MRO of any class, you can write the print statement, and there you can write the class name, for example electric car dot underscore underscore MRO underscore underscore. Now if you run the code, you'll see in the leftmost we have electric car, then we have car, then in the rightmost we have vehicle. So this will show the path Python follows to find methods. So if you try to execute any method, Python first will try to find that method in this class. If Python does not find that, it will go to car class and try to find that. If Python does not find that there as well, it will go to the vehicle class. So the real life analogy would be teacher teaching multiple students. But in hybrid inheritance, the example would be a student who learns from both a subject teacher and an activity coach. So mix of types. I hope you understood this code. Now if that is the case, let me give you a task. So the task is create a base class called appliance. So it is base class, then create 2 more classes. First of all washing machine, then microwave, and both of them inherits from appliance. Then create another class which is smart washing machine, which inherits from this washing machine. Okay, now pause the recording and try to solve this by your own. Have you done that? If yes, great, absolutely great. If you couldn't done that, let's solve this together now. So first of all we have our base class, and that is appliance. Let's say there we have a method power, and in that method we print runs on electricity. Then let's say we have another class. This time the class name is washing machine, which inherits from the appliance class. There we have this wash method, and there we print washes clothes. Then let's say we have this class which is microwave, which also inherits from appliance class. We have a method called heat. There we print heats food. Then we have a class smart washing machine. Now this time it does not inherit from appliance anymore, it inherits from the washing machine. So smart washing machine inherits from washing machine. Okay, and there we have a method Wi-Fi, and there we print can connect to Wi-Fi. Now our classes are done. Here is 4 classes as you can see. Let me minimize the terminal. So washing machine and microwave is inheriting from the appliance class, and the smart washing machine class is inheriting from the washing machine class. So here as well we are having hierarchical and multi-level inheritance. Now we can create object. So let's say The object is swm equal smart washing machine. We use this class. Okay, so in this smart washing machine we have this Wi-Fi method, then it inherits from washing machine class, so it also has this wash method, and washing machine class inherits from appliance class, so it has power method as well. So our smart washing machine has three methods: Wi-Fi, wash, and power. Okay, so let's call them. So we write swm dot power, which is from here, then swm dot wash is from here, then swm dot Wi-Fi, and this method is smart washing machine class itself. Now if I run the code, let me make the terminal bigger, you'll see the output runs on electricity, which is this one, then it prints washes clothes, which is this one, then prints can connect to Wi-Fi, which is this one. Now there are some common questions that beginners ask. For example, can we inherit from two classes? Yes, Python supports multiple inheritance. Then some ask that what if two parent classes have same method? Again, Python follows MRO to decide. So it is left to right and bottom to top. Then lastly, there is another question, which is hybrid inheritance hard? The answer is not really, it's just combining known types logically. So now you know how hierarchical and hybrid inheritance help structure your classes more flexibly and powerfully. So we are almost done with the Python course. From the next videos, I think I will be creating some projects so those make your Python learning more effective and help you to become a better programmer. So that's all for now. I hope see you in the next one. Hey guys, this is project time. So far we have learned many things about Python, but now we have to build some project to get some experience. So first of all, we're gonna build a PDF merger, which aims to merge two PDFs into one. Now in real life, there is some situation where you need to merge two or more PDF files into one. In that case, you just search for a tool or software, use that to merge those PDFs. But now, as we know Python, we're gonna build a tool by ourselves to do this task. First of all, as you can see in my desktop, I have two PDF files. Now, let's say I'm gonna open my PyCharm. Now here, let's create a new project. Now, let's call this project, let's say PDF merger, then hit enter. The project got created. Now right click on it and open in terminal. Let me maximize this. So we need a package to build this program. Let me go to Google Chrome, and here we're gonna use a package called PyPDF. So let me search for that. Now here you can see the link. Let me visit this, and here you can see the command by which we can install that package. Now this package is called PyPDF. So let me copy this command, go back to my PyCharm, and in the terminal, let me paste this command and hit enter. Okay, so the package got successfully installed. As you can see, successfully installed PyPDF 6.3.0. Now let's put our PDF files in this folder, which is PDF merger. So let me minimize a bit this one, and let me copy the files here. Okay, refactor this one to refactor. Okay, so both PDF files in this folder. Okay, let me maximize this again, and now here let me create a file. So I'm gonna create a Python file, and I'll call this merger dot. We don't need to write the .py. So as we are creating Python file, it will be auto appended. I'm gonna hit enter. So as you can see, merger.py file got created. Okay, let me close this and let's start our coding part. Okay, now here in the PDF merger we have a twist. We are going to use a hybrid approach. Our script will run in the console but when we need a file, we'll hack into the operating system to pop up a real browse window. Okay, so first we need our libraries. So we are using PyPDF to handle documents. We install that, but more importantly, we need tkinter or tkinter. You can call this anything. Now, this is a Python's built-in GUI library. Usually, you use this to build full desktop applications like calculators or text editors. But today, we're going to use just a tiny piece of it to borrow its file explorer. So first of all, we need our PyPDF. So here, I'm going to write from PyPDF import. So we're going to import some methods. So first of all, we need PDF writer, okay, and then we need to import the tkinter or tkinter. You can call this anything. That's a bit weird, so I'm gonna call this tkinter. So import tkinter as tk. I'm writing this char form. After that, from tkinter import file dialog. So we want the dialog which lets us take files. Okay. Now, first of all, we want user to select files. So let's build the file selection function. This is where the magic happens. So we start by defining a root. So let's call this root. Oh, first of all, we need to define that method. So def select files, and inside that method, we're gonna define that root. So root, and that tk has a tk method, but with capital letter. I mean the t is capital. Then I wrote this rule, but this will be root. After defining this, we have root dot withdraw. This actually hides the main window. So if I explain in tkinter, the root is the main window of our application. It is the foundation of the container for everything else. You cannot have a pop-up dialog without a root window existing first. However, if we run this command as is, an ugly empty gray box will appear on the screen. We don't want that. We want a clean console app. So we immediately type root.withdraw. This command tells Python I need the root window to exist so I can access the system tools, but I want you to hide it completely from the user. It runs invisibly in the background. Yeah. Now that our invincible root is ready, we can launch the specific tool we need, and that is file dialog. Here I'm gonna define a variable called files equal, and let's call file dialog. We imported that, as you can see. Then here we can find many methods. One of them is ask open file names. So we want the method with the s because we are gonna select multiple files. Okay, and inside there, in the first argument, and the title would be select PDF files, and then we have to define the file types we allow the users to select, and there we can pass this. So we can write here PDF files, so this would be a string, and then in the next part we can write that we allow any name, but at the end it should have .pdf. After that, we will return the files. When users select the files, we will return them. So here we are selecting the files and we are returning the files. Okay, now the merging logic. So we need another function, so let's define that. So def merge pdfs, and in this method we have a parameter which is file underscore list. Yeah? And inside this method, what we can do is we can first initialize a merger. So I'm going to write merger equal, and let's call that PDF writer method. So PDF writer, okay, we are storing that in the merger variable. Okay, for that, let's run a loop. So I'm going to write for PDF in file list. So we'll pass a list, a merge PDFs method. That will be a list. So, and in that list there will be some PDF files paths. So we can loop through that, and in the loop we can tell that merger dot append, and we want to append every PDF files path. Okay, so after doing that, our loop is complete. Now in that function we need to do another thing, that is merger.write. So we have to create a new PDF file with those old ones. So here we're gonna write merger.write. Write means create actually, and in the method we have to give a name. So let's call this merged underscore output. You can name this anything, and the extension would be PDF. Okay, so after creating the PDF, we want to close the PDF. So I'm gonna write merger.close. We can't let the merger to be open after the program has finished, so we have to close that. Yeah, so after closing that, we can write a print statement. So let's do this. I can write here finished, and let's write here saved as merged underscore output dot PDF. So the selecting files function and merging the PDFs function is done. I mean the methods. Now it's time to write the actual main thing, which will get executed when we run the file, the main execution part actually. So these are the functions. These will be executed when we call them, but there should be a root function or the root program which will be run when we just run the file. So that is the main execution part. So let's call this main execution. Okay, so here first of all, when the program runs, we are gonna print that please select your files. Okay, now after printing this, what we are gonna do is we are gonna write another variable called PDFs, and there we are gonna call that function we defined above, which is select files. And now this function will get triggered, really this one, and user can select PDF files there. Okay, now there we can write that if PDFs, if that is the case, I mean if user has selected some PDFs, we can print that with a string formatting actually. Here let's write you selected, then let's inject len, and here let's pass the PDFs, then just files. So if user selects 2 files, here it will print you selected 2 files. If he selects 3 files, it will print that you selected 3 files. After that, we're gonna call merge PDFs method, which we defined here. Okay, and here we're gonna pass the PDFs. So PDFs. As you can see, in this method we accept a file list, and we are passing that file list. This will pass the paths of the files. It will happen when PDFs are selected, but let's say if user does not select anything, so we'll handle that in the else part, and there we will just print that no files selected. Now as long as this program runs, we want the window to be opened. So for that, what we can do is we can write the input function, and here we just write press enter to exit, press enter to exit. Okay, this is just because we want the program to run when we are going through selecting and merging process. Okay, so our program is mostly done, so let's run this project. Okay, as you can see, please select your files, and I have this Python thing here. As you can see, it opened my Finder. If you are on Windows, it will open your File Explorer. Let me see what is that folder, which is PDF merger. Now this is getting too much embarrassing because I am not able to find the files, I mean the PDF files, where they are located. So let me do one thing. Let me close this, go to the project, stop that. Let me minimize this and move these files in the desktop. I can find the files easily. This has nothing to do with the project. Now let me run the file again. Okay, as you can see, it is trying to open my Finder. If you are on Windows, it will try to open the File Explorer. So in the Finder, I'm gonna select these 2 files and click on Open button. And if I go there, as you can see, the file got created. So Now if I try to open this in my Finder, as you can see, the merged output.pdf file got created. Okay, I haven't closed the program, so the job is finished. Saved as the new file got saved as merged output.pdf. Now I have to press enter to exit. Okay, so now I can open the merged PDF file. As you can see, awesome. So our PDF files, that two files got merged into one. So how cool is that? So congrats, you have built your first Python project, which is a cool tool which can merge two or more PDF files into one. I hope you enjoyed this lecture. So if you enjoyed this, please leave a like and make sure to subscribe to this channel. Let's see you in the next project. So let's build an internet speed tester project. So let's check if your ISP is giving you the speed you pay for. We are building a CLI internet speed tester. For that, we are gonna use a package called speedtest CLI. First, let me create a project and call this speedtest. Hit enter. Let me create a new file and let's call this speed check. Enter, file got created, and right click again, open in terminal. The terminal got opened. Let me maximize this, and we are gonna use a package called speedtest CLI. So let's check that first in Google Chrome. So I'm gonna write Python speedtest CLI. Okay, as you can see, this is the package. So let me copy the command, go to PyCharm, and let me install that. Hit enter. Okay, as you can see, the package got successfully installed on our project. So there would be just one method, so let's call that method. So the method name would be check internet speed. Okay, now we don't have this method, we're gonna create this, but we will have an input function. So this execution should not stop implicitly. User has to hit enter to stop execution of the program. So here in the placeholder, I'm gonna write press enter to exit. Okay, now let's define that function. It is check internet speed, and first of all we need to import that package. So I'm gonna write import speed test. So first of all, let me write the print statement, and there we write internet speed tester, then again the print statement, and here we write initializing. Please wait. Then we have to write some try and except block. So in the try block, now why there is wiggly lines? Oh shit, I haven't write the def keyword. Okay, so in the try block, first up we have this variable st, and here we write speedtest dot and call the speedtest method with the capital S, and then we write print finding best server, and then write st dot get best server method, and after getting the best server, we're gonna write print testing download speed, and in the next line we write a variable download underscore mbps equal st dot and call a download method, and here we will get result in bits. So we want to show the result in mbps. So what we're going to do is we're gonna divide that with 1 underscore 0 0 underscore 0 0 0. Okay, now one more 0 here. After that we write again print, and here we write testing upload speed, and let's define a variable upload underscore mbps, and here we write st dot and call the upload method, and again the result is in bits, so we need to divide by 1 0 0 0 underscore 0 0 0. Then we'll have a ping variable. Here we're going to write st dot results dot ping. Now after that we will have a bunch of print statements. First of all, let me give a backward slash n for a new line, then Let's do some concatenation. Again, quotations equal, then multiplication by 30. Then again, a print statement, string formatting. Here I'm gonna write download, and I'm gonna inject that variable, which is download mbps. Then I'm gonna give a colon sign and dot to f. So that means I want 2 digits after the period, and after the braces I'm gonna write mbps. Now let me copy this. Now this time we're gonna write upload, and here let's inject upload mbps. For that, let's work with the ping. Let's inject the ping variable here. We don't need this anymore, and here it would be a mess. Then again we will have a print statement, then a equal sign multiplied by 30, prints 30 equal signs. Okay, after printing, and our try block is done, so we need to write our except block. So in the except, if we get any exception, we catch that e and just write a print statement, and there we have string formatting, and write error, and let's inject e. Okay, so we are done. Let me run the file. As you can see, first it is initializing, then it is finding web server, then testing download speed, testing upload speed. Is happening one by one. First this line got executed, then it went into this, started printing this and doing these executions. As you can see, my download speed is 49.16 mbps and upload speed is 49.53 mbps. The ping is 15.683 ms. So I can hit enter to exit, and I can run the program again. Let's see if it gives similar results. So it is finding best server, testing download speed, now testing upload speed. As you can see, the result is somewhere near what is in the previous result. So congrats, you have created your second project with Python. So see you in the next one. So now let's create another project, which is CLI password manager, and there we will use encryption to make that secure and paperclip to auto copy the passwords. First of all, let me create a new project, and I'm gonna call this password manager. Okay, but hit enter. The project got created. Let me make this full screen and open in terminal. Okay, so here now let's install our packages. So we need 2 packages actually, so I'm going to write pip install. First one is cryptography, and then we have paperclip. Then hit enter. The packages are being installed. Okay, so the installation is complete. Now let me create a Python file, and I'm gonna call this pass manager. Let me close this, and first let's see if everything is okay or not. Print hello. Okay, everything is working fine. Let me remove this. Now before we build the project, we need to import our packages. So first I'm gonna write from cryptography, and there we have a thing called fernet, and from there we want to import fernet. Now this is used to encrypt something. Then we need the built-in module, which is the OS module. So we are importing this to check if a file exists or not. Then we need some more built-in modules. So for example, we need random. Let's import string, and lastly let's import the paperclip, which we installed a moment before. Okay, now first of all we will think about the security. We need a master key. Think of this like a physical house key. We will write a function to check if a key already exists. If it does, we will load it. If not, we generate a brand new one and save it as secret.key. Now here is a warning. If you lose this key file, you lose all the passwords forever. So first of all, I'm gonna write if not, and we're checking if a secret does not exist, so we are gonna create one. So let's check with the OS module that os.path.exists. Okay, and there we want to check if secret.key exists or not. If that does not exist, then we create a key. So key equal Pernet dot generate key, and we call this method. Then we can write with open. So we are gonna open a file and we're creating. So we're gonna name this secret.key. Now after that, in the next argument or in the next option, we will pass a mode, and the mode is WB, which is write binary, and we give as, and we want to call this key file, and inside that file we will write, meaning we will insert that key which we are generating here. Okay, so this is we are doing when the secret.key does not exist. But what if this already exists? So then we will handle that in the else block, and there we won't generate anything, but we'll open the file. So with open, and we want to open the secret.key, and here the mode would be RV, which is read binary, and again we'll do as key underscore file, and there I will write key equal key file dot read. I hope this made some sense to you. If it did, let's move to the next part. So this part, if I divide the code into some parts, this would be just the setup of the project, and here we are just loading the key. Checks if we already have a key, otherwise just creates one. So this part was done before, and the next part would be initialize the encryption tool. So let's do that. Let me have some space below this, and now let's call this variable tipper, and here we call the format method and pass the key. Now here it is telling that name key can be undefined, but let's ignore that for a moment. Now we need some helper functions like generate password, then add password, and get password. So first let's define the generate password function. Now this part is helper functions. So the first one is generate password. So generate underscore password, and let's write logic to generate a password. Now let's have some string here. Here I'm gonna write generates. Now here first of all let's have a string. So basically a multi-line string, you can say. So I'm giving 3 quotations here, and inside that I'm gonna write generates a random 12 character secure password. In the next line, let's have a variable called chars equal and string. We imported string, as you can see. Then there we have this escalators. Then let's concatenate with some string digits, and let's also have some special characters like exclamation, @ and $%. Okay, for that let's have our password variable. So password equal, let's have an empty string first, then dot join. So in the string we want to join that, and let's write random dot choice. So we are telling to choose random things from chars, then for underscore, this is just a variable in range 12. Okay, and now beside underscore you can end this anything. This is just normal variable, and after generating the password we want to return that. We return the password. Okay, now generating password functionality is done. Now we will have another function, and that is add password. Let me define that function. So I'm going to write add score password. Let's have multi-line strings here as well, and here let's give a string prints, flips, and saves a new password. Now, whenever we run this method, we want to allow the user to write some input, and he has to give a name. So I'm gonna write the input function, and here we are asking for account name. So I'm gonna put that in the placeholder, and for name, let's have a choice. Now here, I want to give the user some choice. So for that, I'm gonna write the input function again, and here I'll ask a question that generate random password. Then the option is Y or M, which indicates yes or no. And whatever user gives, we make that to lowercase. So if he writes in uppercase letters, we'll turn them into lowercase. So I'm going to call the lower method. Then let's check if choice is equal Y. If that is the case, then let's generate a password. So I'm going to call this pwd, and let's call the generate password function. And then we'll print that as well. So I'm going to write print. Let's have a string formatting. And I'm going to write generated. And let's insert wd. Okay. So if choice is Y, we're going to do this. But what if he writes no? So we'll handle that in the else block. He may write other things as well, but let's not account that here. And in the else block, we'll handle if he does not write Y. If he writes N or any other thing, some gibberish, we'll handle by this code. So I'm going to write pwd equal input, and there we'll ask for a password. So he can write now. So enter password. Okay. So this is manual. Now let's go outside of the if else block and let's check the encryption magic. So encryption magic. So the password was generated by random strings or a user password, does not matter. We have to encrypt that to make the password secure before storing. So here, what I'm going to do is I'm going to have another variable, and I'm going to call this encrypted pwd, means password, and I'm going to write equal tipper dot encrypt. I'm going to call a method, and there we'll write pwd dot encode. Let's call the method, and after that I'm going to have the decode as well. But I explain that a bit later. After writing this line, write with open. Now we're going to store the passwords in a passwords.txt file. So let's create passwords.txt, and here we are opening that file with mode A, and let's write as f. By the way, you can name this anything, and here we can write f.write, and let's have a string formatting. Let's write name, the encrypted password. So here the account name and password for that account name. Okay, so if I explain this line here, this line is a chain reaction. We convert the password to bytes, to machine bytes actually, and tip it into a secure mesh, then turn that mesh back into a string so we can save it in our text file. Now after we write the name and corresponding password, we can have a new line here as well. And for clarity, we can write a print statement and just write saved to indicate the user that password has been saved. Okay. Now we will have another thing, means another function, and let's call this get password. Get password. Let's write here finds, decrypts, and copies password. So at first, let the user select or type for which account he is trying to find the password. So let's have a variable called a target. And there, let's call the input function. And here, let's have a placeholder account name to find. And let's have another variable called found, and the initial value would be false. Now here comes the main logic. Here we will check if os.arc.exists, and let's try to find the passwords.txt file where the passwords are stored. Let's write with open,
Then let's write the password dot txt, and the mode would be R in read. Let's write as f to have a shorter variable. Then we'll have a loop. So for every line in the txt file, and we'll run the loop in the f file, and in the loop we'll check if then this pipe sign in a line. So if in a line this symbol exists, we'll have some variables. First of all, name, which holds the account name, then attributed password, let's have a short term here, and equal, and let's do some stripping on the line. So line dot strip, call that method, and let's do some splitting as well. So split, and we want to do split with this symbol. Okay, so inside this block we'll have another if block. So if name dot lower, call the method, and equal target dot lower. If both are same or matches, now we have to do some decryption magic. We have to match that decryption magic. Let's have a variable called decpwd, so decrypted password expense, and here we can write cheaper dot decrypt, and here we can write n pass. Let me do one thing. Let's not call this pass. Let's call this pwd password. So it stays same everywhere. So I can write here and pwd dot encode, and then write decode as well to pack the mess up. After that, let's print that as well. So print, and let's have a string formatting, and let's write password, assert, encrypted password, and now we want to auto copy that password as well. So we have to use that paperclip package for paperclip. So I think I made a mistake. Let me check what package I have installed. So I installed a package called paperclip, but the actual package is paperclip. That's a mess. So let's do one thing. Let's uninstall that. So I'm gonna write pip uninstall paperclip. Okay, yes. So successfully uninstalled paperclip. And again, let's write pip install paperclip. Okay, so successfully installed. Let me rewrite this import statement, paperclip. Let's go back to there, and here, let me close this terminal. This one here in the paperclip, we have this method called copy, and let's pass what we want to copy. We want to copy the encrypted password. After that, let's print copy to clipboard. Let's put that inside some parentheses, and let's make the variable found equal true, and then just break the loop. After that, let's check if passwords.txt file was not found. So let's write if not found. If that is the case, we want to print account not found. Okay, so all the functionalities are done. Now it's time to write our main loop, which will get executed when we run our file. So this will be our main loop. Here, let's write while true. So the loop should not stop automatically based on some logic, but we will give our user control. So if he choose that, then the loop will be stopped. Otherwise, it will keep running. So inside the loop, let's write the print statement. And here, let's have a backward slash n for new line. And here, some dashes. Then let's call this password vault. And after printing that, let's have a mode there, write input, and let's indicate that A to add, then G to get, and Q to quit. So user has to write these letters to perform some actions in the program. So after he gives some input, we turn them into lowercase, and after that we check if mode equal Q, meaning user wants to quit the program. So we'll break the loop. Otherwise, I'm gonna write an elif statement. If mode is equal a, means we want to add a new password. So let's call the add password method. Now here I missed the colons, and after that we will have another elif. Here we'll check if mode is equal g. If that is the case, that means user want to get a password. So let's call the get password method. Okay, and if it types anything else, those inputs are invalid. So let's print invalid input. Okay, now let me run the program. Let's hope for the best. And here, as you can see, it printed is password bolt, and it is asking me what I want to do. So I want to add. So I'm gonna type a. So here it executed this add password method. Here, as you can see, it is asking for an account name. Let's call this Fadil, and here it is asking generate a random password. So if we write y, it will generate a password by its own. But if we write anything other than y, it will give us an option to enter a password by our own. So let me give here y, so it generates a password for us. As you can see, the password got generated and it is saved. As you can see, saved in the password.txt file. Now, if I check, you won't find that file because the program is still running. It hasn't finished executing. So if I stop this, as you can see, the secret.key got created. So this got created when we executed the file, and this passwords.txt file got created when we add that password. Okay, and now if I run that file again, as you can see, it is giving the options again. So now let's add another password. Now this time let's have an account name called John, and it is asking if we want to generate a random password. Let's give no. Now here we can write our own password. Okay, if we give enter, you can see that password got saved. Now I can write here Q to quit the program. You can see the execution stopped, and if I run the program again, it is giving the options again. Now if I write here G, then hit enter. Now it is asking for which account we want to get the password. Let's say I want to get the password for the account Adil. If I hit enter, as you can see, it printed the password and it is telling that copied to clipboard. So let's see if that got copied in the clipboard. Let me go to the editor, and here let me do Command V. As you can see, the password got copied automatically. I can paste that here as well. Here, as you can see, this one and this one matches. So that means it was copied automatically. Okay. Now if I write here G again and write here John, you can see it gave that password and copied it to clipboard. If I click on Ctrl V, you can see it gave that password. Now we are getting this password as a string format, in a readable format actually. But if I quit this and go to the passwords.txt file, as you can see, the passwords are stored in a long text format. So this is a secure encrypted text. So anyone, so any normal person cannot tell that what is the actual password of that account. So this is stored as a secure encrypted format. So it is hard for the hackers to know the actual password of that account. As you can see, the secret.key is the key which was generated while we first executed our file. And now if we change this or lose this key, we can't decrypt this password to the normal passwords or the readable formats. So as you can see, it is a beautiful and a great tool or a project for a beginner to build. So I hope you enjoyed this project and this video. So if you really enjoyed this video, give a thumbs up and leave a subscribe to this channel. This will help the channel grow. So Thank you for watching. See you in the next one.
Now it's time for we build a system monitoring tool in Python. Now this system will monitor and keep tracks of your CPU and RAM usage in real time. Instead of just printing numbers, we will build visual progress bars that change color based on how hard your computer is working. So let's call this project system monitor and hit enter. The project got created. Let me maximize this. Now here we will use some packages. So let me open the terminal here. Let's install them. So pip install. First of all, we need psutil. Now this package gets the hardware stats, meaning the usage of CPU, RAM, and etc. Then we need another package, and that is Coloroma. So this makes the text colorful, like green, red. So let me hit enter. So as you can see, the packages got successfully installed. Let me close this. Oh, before that, let me create a file actually. So new Python file. I'm gonna call this sysmon. Yeah. Now we can close this. First of all, let's import our packages. So I'm gonna write import psutil. Then we want to import time. This is an inbuilt module. Then let's import class module as well. And after that, from Coloroma, we import for, then style, then init. Okay. Now after that, let's initialize Coloroma. So colors work on Windows. So initialize Coloroma. So colors work on Windows. So I'm gonna do init, and here let's write auto reset equal true. So this is for Windows because Windows CMD prompt does not understand the color codes, but in Mac and Linux, the terminals already understand colors natively. So this init doesn't need to do any translation work here. So it mostly sits idle. Now after this, we need our functions. So first of all, we'll have a create bar function. So create underscore bar, and there we'll accept a parameter. So that would be percentage. And let's have multi-line string here. And let me write here creates a visual text bar with these signs. And after this, let's have a variable called total underscore length equal 30. So you can make the bar longer or shorter here. So the more number you give here, the bar will be more wider or longer, you can say. Let me have some spaces below. Okay. After that, let's calculate how many types to draw. So let's write field underscore length equal, let's call this int method. So it turn any floating point numbers to integer. Then here we pass total length into, then the percentage which will be passed in the function, and we will do floor division with 100. And after doing that, we have to construct the bar string. The bar equal that pipe, then into field length. We'll multiply this sign with that number, then concatenate with a hyphen sign, and we'll multiply that with total length minus field length result. And after that, we're gonna return the bar. Okay, let me minimize this. After that, we'll need another function to get the color actually. So def get color, and here also we will have that percentage parameter. Here we're gonna write returns green for low, yellow for medium, and red for high. Now after this, let's check if percentage less than 50. If that is the case, we'll return 4 dot green. Okay. Then elif percentage less than 80. If that is the case, we want to return 4 dot yellow. I have to return this actually. and else if both are not true, we want to return 4.red. Now the defining of the functions are done. Now it's time for the main program. So main program. Now here first write the print statement and let's print initializing monitor, and after that let's have some try and except block. So let's try, and in the try we will have a while loop and it would be true, so the loop runs as long as the user does not exit the program. Now here let's have a variable CPU underscore usage, and here we can use this package which is psutil, and let's write psutil dot cpu percent, and let's give an interval, so interval, and that would be 0.5, and let's check the RAM usage, so psutil dot virtual memory dot percent. Okay, after getting them, now it's time for os dot system. Now here we give cls. Now it is for Windows, so if cls has been typed, it will clear the console and it will happen on the Windows system. So we are gonna write this logic here. So os dot name equal nt. Nt means Windows. Else means if that is Mac or Linux, the command would be clear. Now after this line, let's print something. So print, and we want to print style dot bright. So this should be bright, and then let's have a new line /n, then some hyphens. Let's have the string which is live system monitor, and again a /n for a new line. Now after that, let's have our CPU display. So CPU display. So first of all, let's have a variable called CPU underscore bar, and let's call this createBar function and pass the CPU usage. Then let's have another variable called CPU color, and let's call that, the function name is getColor. So getColor, and let's pass the CPU usage again, and after that let's print them. Print, let's have a string formatting, and there let's write CPU usage, and let's insert CPU color, and after that in a square bracket let's insert CPU bar, so the bars should look nice. After that let's insert the CPU usage. After that let's give the percentage sign. Now it's time to display our RAM usage. So RAM display, like CPU, we'll have another variable called RAM underscore bar equal createBar. Let's call this RAM underscore usage, then RAM underscore color, and let's call this function getColor, and again pass RAM usage, and it's time to print. Let me copy this line, actually paste it here, and here I'm gonna call this RAM usage, and here let's have this RAM usage. I think that would be RAM color actually. RAM color, then RAM bar, then RAM usage finally. After that, let's write print, and here I'm gonna write style dot reset all to reset, and let's concatenate with this. I'm gonna have a /n for a new line, then bunch of dashes, and after that I'm gonna write the print statement again, and I'm gonna tell the user to press Ctrl plus C or Command plus C to stop. Okay, now if this try block has some exception, we have to handle that. So I'm gonna write the except block. So if any keyboard interrupt happens, we're gonna print with a /n obviously, and we're gonna print that monitor stopped. So our program is done. So let me make this bigger and execute the file, and as you can see it is printing. As you can see, it is showing the CPU usage and RAM usage with bars. I have to press Command C to stop. I think it's Control C, so both are not allowing me to stop. So let me stop from here actually. So as you can see, it is printing the CPU usage and as well as the RAM usage after a little time frame actually. As you can see, the CPU usage, then the RAM usage, again the CPU usage, RAM usage. Let me run this again. Let me write Ctrl C to stop the program, but it is not working. Command C, it is not working. So I have to stop the program manually from here. Okay, so I researched a bit and found that this is a PyCharm issue actually, I think. So if you run this on a terminal, the Control C should stop the program, or Command C, and this is also happening. Uh, and this red error, term environment variable not set, is also because of PyCharm, I guess. That is what I found on the internet. You don't have to worry about that, but our program is working actually fine. I'll put these codes in my GitHub, and you will find all the codes of previous projects as well in my GitHub. And that's all for now. See you in the next one. Welcome back. Today we are building a screen recorder. We are essentially going to take screenshots really fast, like 20 times a second, and stitch them together into a video file. So first of all, we'll need some packages, and those are OpenCV Python, NumPy, and PyAuto GUI. So before we install them, first we have to create a project, obviously. So let's call this video recorder. Here the project got created. Let me open this in our terminal, and let's create a Python file. Let's call this recorder, and let's close this menu. And first of all, we need our packages. So pip install. The first package is opencv-python. Then we need NumPy. Then we need PyAuto GUI. Let me hit enter. It is downloading our packages. This will be done in a few moments. This time the packages are a bit big in size. Let's wait a bit more. It's time for NumPy. Almost done. Okay, so the packages got installed successfully. Now it's time we do our imports. Now here we need CV2, meaning the OpenCV actually, the NumPy to handle the image data, and PyAuto GUI to capture the screen. We also need to define our screen size instead of hard coding numbers. We use PyAuto GUI.size, so it works on any monitor automatically. It will get the actual size. First of all, let's import CV2. Then let's import NumPy as np. Then we're going to import PyAuto GUI. Now first of all, we need some configuration. Let me close this terminal. And the first configuration, we need the screen size. So screen_size, and let's use a tuple, meaning the tuple method actually, and there let's pass the PyAuto GUI.size, which will return the monitor size. Now after that, so here we are getting screen, and after that we have to generate a file name. Let's do this by timestamp. So generate file name with timestamp. Let's have a variable called timestamp equal datetime. So we need to import datetime. So import datetime, and here let's use that. So datetime.now, I call this method, then again dot, then string ftime, and here we give some options. So %h, so it would be hour, then %m for minute, then %s. After that, let's write file name, and let's have a string formatting here, and I want to have the string recording underscore timestamp dot mp4. Now after having a file name, we want to set a codec actually. So set codec, so it would be a compressor. Let's have a variable for cc equal, let's use cv2 here, dot video writer underscore for cc, and we allow and we give here star, then in quotations we give mp4 v. Now here it is showing a yellow squiggly line, but let's not care about that for now. Let me have some space. Now it's time for create video writer, and also keep in mind that 20 fps is a safe speed for Python recorders. So we will have a variable called out. Let's use cv2 again, and video writer, and the options we give file name, then the codec for cc, and the frame per second, meaning the fps, which will be 20.0. then we give the screen size, as you can see, this one. After that, let's write the print statement again, and here we have a string formatting, and let's print recording started. For that, print again string formatting like saving to, then file name, and again print, and let's write here press q inside the preview window to stop. Okay, done. Now for that we need a try and except block. So try, then while true, meaning as long as user does not quit the program explicitly, we want to run the loop. Then here we have to write another variable. Let's call this image, and here we have to capture the screen. So let's write iAutoGUI dot screenshot. So the first step is capture the screen, then the second one is convert pixels to a numpy array matrix. Actually, let's have another variable frame and np. As you can see, we are calling numpy as np. So np dot array, and let's pass the image. And after that, in the third step, we have to do some color correction. Now keep in mind that OpenCV uses BGR, but iAutoGUI gives us RGB, so we must switch them. Now these are some color formats. You don't have to understand them fully, but keep in mind that BGR means blue, green, red, and RGB means red, green, blue. So in the first place there is R, which stands for the red color, but OpenCV uses BGR, so first it uses the blue color actually, so we have to switch the colors actually. So again, I'm gonna write the frame variable, we'll modify the previous value. That I'm gonna write here cv2 dot cvt color, it's a method, and here I'm gonna pass the frame, the previous frame actually, this one, and cv2 dot color underscore RGB to BGR. So this will convert or switch the colors. Okay, this is also done. And after that we have our step 4, and that is write those frames to a video file. So I'm gonna write out dot write and just pass frame. For that we have this 5th step, we have to show the preview. Show preview. Now this is optional, so optional, you can comment this out to run faster, but let's keep that. I'm gonna write cv2 dot IamShow, so it will show a preview, and here I'll write a string live recording and just pass the frame. Okay, and after that we have our step 6, and that is stop logic, and for that user need to press the Q. So here I'm gonna write if cv2 dot wait key, and we can give here a delay, for example 1 millisecond, then equal rd equal q, then we want to break the loop. Okay, so this wait key argument waits that much millisecond for a key press. Now after this try block, this one actually, we will have to handle the exceptions. To accept, let's do some keyboard interrupt, and I'll give here just pass, and let's have a comment handle ctrl plus c, control c safely to stop the program actually. Now we need to do some cleanup as well, so the program stays optimized. So clean up. First of all, here we have our out variable, where it is this one, which is outputting. So we have to release that. It will save the file actually. Then we are gonna write cv2.destroy all windows. It will close the window which will be opened while the process is going. Then after that, we're gonna just print first of all a /n for a new line, then success, video saved. Yeah, now let me run the program. Let's see if this works or not. So it is showing some error. So it executed the file, then printed saving to, it generated a file name. As you can see, this file name it generated. Then we have this error. Now this error is happening because behind the scenes the library which handles the image processing is called Pillow, and I'm using Python 3.13, which is very new. I think Pillow does not support this or is not fully compatible. Let me stop this thing, open the terminal here, and then run the command pip install --upgrade pillow and pysqueeze. Hit enter. Okay, let me run the code again, see what happens. So it is asking a permission. So PyCharm CE would like to record this computer screen and audio. So open system settings and let's give the permission. And as you can see, in the previous execution there was the error, but it exported a video actually, and this time as well it exported a video, as you can see. Let me run this again. So as you can see, it is taking multiple screenshots. Let's see, it should take 20 screenshots. I hope 20 screenshots should be done by now. Okay, so let me stop the program. So it is telling that video got saved. Here it is. Let me open this in my Finder and let's try to play this. It's telling that the document could not be opened, but it created the video and we have some errors here. Let me execute the file again and let me stop manually. I think PyCharm does not support that control Q or something like that. A video getting saved, okay? It's not getting opened. Okay, so it is telling that file isn't compatible with QuickTime Player. Let me check with a one-line video player. The video actually got created, but this Mac's default video player could not play the file. Let me go to Google Chrome and search for an online video player. Let me open this. Now I have to drag and drop that video file here, if that supports. Okay, it is a video file but does not have any content. Let me try with this one, and with this one. Now the video is not watchable and we have these errors, and that is solely because of this one, which is we are having the screen size from py_auto_GUI.size, but my Mac has some retina display and this is causing some issues. I researched. So for the fix we have to do this. So first we have to take a screenshot, then from that screenshot we will have the frame height and frame width, and we will use that for screen size. So we are not taking the screen size actually automatically from py_auto_GUI, but we are first taking a screenshot and from that we are calculating the screen size. So now let me run this file again. Let me see if any error. This time there is no error. Okay, so it is telling that video saved. So let me open in Finder. As you can see, now the video is watchable. As you can see, how cool is that? Okay, let me close my browser, go to PyCharm. Let me delete all the things. Let me close this and let's run the file. So you can see it is taking screenshots. So I'm switching my screens and you can see the preview window. If I click Q here, it will quit the recording. As you can see, it says success, video saved. And now if I go to the menu, you can see the video file. And if I open this in my Finder, as you can see, video got created and it is fully playable. As you can see, so how cool is that? You have successfully created a video recorder with Python. So I'll put this code in my GitHub repo. To make sure to like and subscribe if you enjoyed this video, and I'll see you in the next one. Now it's time for another cool project in Python, and that is speech recognition and text to speech. Okay, so let's create our project. I'm gonna call this SR, means speech recognition, then TTS, meaning text to speech. Okay, I'm gonna hit enter to create the project. Let's make this full window and let's create a Python file. Let's call this project srtts. Okay, and now let's open in terminal. Now to build this project we need some packages. So first of all we need pyttx3, then speech recognition, and pyaudio, those three packages. So what I'm going to do is I'm going to write pip install then pytttsx3 to keep the spelling correct. So pytttsx3, then you have speech recognition, then another package is pyaudio. If the spelling correct, or you can search for them in Google as well. For example, if you search Python pytttsx3, you'll find this link, copy this command and install. Then you can search for speech recognition, you'll find this, install, copy that and go to your PyCharm and run. Then you can search for pyaudio, open, copy this, go to your PyCharm and run. Or you can write like this, all the three packages with just one command and hit enter. So it will take some time, let's wait for that. However, if you are on Windows and pyaudio gets failed to install, so what you have to do is first you have to run pip install pip win. After that you have to write pip win install pyaudio. So this is solely if you face any error in Windows. Otherwise, if you run pip install pyaudio and if that works, you don't have to worry about these two commands. But if you run pip install pyaudio and face some issues, just run these two commands. Okay, I was telling about errors in Windows, but it seems that I got error in my Mac as well. Okay, after looking at the errors, I found that in Mac you have to have an underlying C library called PortAudio to work the pyaudio properly. So let me install that. I'm gonna run the command brew install PortAudio. Okay, that is done. Now let me run that command again, which is pip install pytttsx3 speech recognition and pyaudio. This time it should work, hopefully. Okay, so this time it worked. Now let's start our coding part. Let me minimize this and close the terminal. Now first of all let's import our packages. So import, so first of all pytttsx3, and then we have to import the speech recognition library, and let's call this sr in the short form. Then let's have a function which is speak, and here let's have text as parameter which will be passed, and here we are doing converts text to speech. So to convert, first we need an engine, so we write engine then equal pyttssx3 dot init. We have to initialize that. Now there is an optional part, and that is to change voices. So first of all I'm going to write here optional. So this is optional, so you can change voices, 0 for male and 1 for female. Let's have a variable called voices. Then let's write engine dot get property, and we want the properties of voices. Now by default it is male, but if you want to use the female voice, you can write here engine dot set property, and here we want to set property for voice. Then in the next option I can write here voices and give here on dot id. Okay, so now it will use the female voice. After that I write here the print statement, then let's do some string formatting, and here let's write bot, and let's insert the text which we are getting in the parameter. Then we will tell the engine to say. So let's write engine and call the same method and pass the text. After that we write engine dot run and wait. Okay, so text to speech functionality is done. Now it's time to create the function, so the program will listen to us and convert the voice to text. So let's create another function. So this will be listen, and here let's write a string. And here I'm going to write listens to microphone input and converts to text. Okay, let me have some space below. For that we need a recognizer, so let me create a variable first. So recognizer equal sr dot recognizer. This sr is this speech recognition package actually. Now for that we write with sr, we'll use that package again, and we'll call the microphone method as source. We'll use the microphone as source. Then we're gonna print that user listening and click now. Okay, and after that we use that recognizer, then dot adjust for ambient noise, and we pass our source, which is the microphone, and here we give a duration equal 1, which calibrations for 1 second to remove background static. Now after that we need some try and except block, because there can be some failure. First of all we need the audio, so audio so equal recognizer dot listen. So our program will listen now to the source, which is the microphone, and while listening we'll tell to print that recognizing. Then let's write a variable called text. Now we will use the recognize Google method from that recognizer. So recognizer dot, we have some services which transforms the speech into text. So previously one famous was recognize Google. Previously it worked perfectly, but let's see if this free API from Google is still available or not. So let's pass the audio to Google and let's see if it can transform the speech to a text. If Google recognition is not available, we will use the Bing. Okay, so after this let me write the print statement, and here let's have a string formatting, and I'm gonna write you said, then inside quotation let's insert that text. After that let's return text dot lower. After try we should handle any exception, so except sr dot unknown value error. If that happens I will print sorry I did not catch that, and just return empty string. And there can be another exception, so exception dot so except sr dot request error. If that happens, so we will print could not connect to Google API and just return empty string. Now it's time for the main loop. So I'm going to write while true, meaning if user does not explicitly stop the loop, it should run infinitely. So first of all, the step 1 would be listen for input. So I'm going to write here user underscore input, and let's call the listen method. So our program tries to listen what user tells. Then step 2 is our logic handler, and there we'll check if quit in user input, if user tells anything that has this quit word, or exit in user input. If that is the case, we'll call that speak method, and here we'll write shutting down and goodbye, and just break the loop. Otherwise, if hello word is there in user input, means if user tells anything that includes the hello word, then we want to speak hi there, how can I help. So our program will say this contents. Then let's have another elif statement, and there if name is there in user input, we'll tell our program to speak that I am a Python script created by Adel. Then let's have another elif, and for that, if user input is there, then we'll just call the speak method, and let's give a string formatting, and here we'll write you said, and let's insert the user input. Okay, so the program is done. Let me run the file. Now as you can see, it is asking permission to access the microphone. I will allow this. So it is listening. As you can see, it is understanding my speaking, and it is printing. As you can see, so how cool is that? So it is understanding what I am telling, and let me tell hello. As you can see, it is printing hi there, how can I help. Can you listen the audio? I believe you can't listen the audio because I'm recording, and the audio is being played in my Mac, so that is not being recorded, but I can confirm that it is speaking with me whenever I am telling hello. So the code again, and hello, this is Adil. As you can see, it is recognizing me, and it is asking question as well. So congratulations, you have built your first uh, mini voice assistant, you can say, which uh, turns text into speech and speech into text, so it understands your speaking as well. So I hope you liked the project. Build this. You will find the code in my GitHub repo. So if you found this video helpful, leave a like and subscribe to this channel. See you in the next one. Hello everyone, again it's project time. In this video, let's build an awesome TODO app by which you will understand your learning stage, and you will be able to feel that how much effort you have to put further. Believe me, this is a great project as a beginner which will help you understanding many concepts. So let's get started. First of all, let's create a new project, and let me call this my TODO app. Hit enter. Project got created. Let me create a new Python file, and I'm gonna call this TODO app. Okay, let me maximize this and open the terminal. Let me minimize the menu, and here this project we're gonna use some packages, or frankly one package actually, and that is Coloroma. So let's install that. Pip install Coloroma. Hit enter. The package got installed successfully. Now for a moment, let me close the terminal and import our modules. First of all, let's import the JSON module. It's an inbuilt module and you don't need to install anything. However, let's import the OS module as well, which will help us to work with the files. Then from Coloroma, we want to import the core module, then style, and finally the init one. Okay, now we have to initialize the colors. Basically for Windows, Mac and Linux terminals already understands the color codes. So I'm gonna write init, and here write auto reset to true. Now here I'm gonna write file underscore name. So we'll be storing the tasks or the to-dos in a JSON file. So we need to work with file system as well. So in the file where we're gonna save the user to-dos, we're gonna call that my underscore tasks.json. Okay, now JSON is a very important topic in programming. When you will be building some very large scale or medium scale softwares or any kind of softwares, in the majority cases when you will be dealing with the data, the possibility of the data format is to be in JSON. So it's a really important topic which will be covered in this video. So our tasks will be saved in this JSON file. First of all, we need a function to load the tasks from this JSON file. So we will save the tasks as list of dictionaries in the JSON file, and whenever the program runs, first we'll try to load the tasks. So for that, we write a function def load underscore tasks, and let's have a string literal here. And here I'm going to write loads the list of dictionaries from the JSON file. So first of all, let's check if the file not exists. So I'm going to write if not os.path.exists, and we're going to pass the file name, the path of that file. And if that is the case, we'll tell the program that we don't have any task, so empty list. Okay, and then we'll have a try and except block. So we'll try to open that file, so with open, and we pass the file path or file name actually, and here we have the read mode, and as let me call this f, and we just return json dot load and just pass f. Okay, and if anything exceptional occurs, except, and here there can be two scenarios. For example, json decode error. So if any error occurs regarding decoding the JSON file or the JSON data actually, and there can be another kind of error, and that is the IO error. And if that happens, we'll return empty list. Okay, so now this function actually loads the data in the program. Okay, for that, now we need a function to save the task. So let's create a function. So def save underscore tasks, and there tasks will be provided in the parameter. Let me have some space below. Now what does this function does? It does saves the current list to JSON file. Okay, now first of all we write with open, and again we pass the file name or the path if you have any different folder to save, and then we have this mode which is write mode, and again let's call this as f. You can name this anything, file or whatever you wish. Then here we're gonna write json dot dump, and we want to dump the provided task, so it will put the tasks list in the JSON file, and the indent would be 4. Now this indent tells Python to format the JSON with 4 spaces of indentation per label. Now you don't have to go anything deep regarding this one. Let's move to our next function, and that is to view the tasks. So user will try to view his tasks, so we are going to allow by writing the view tasks function. So let's have another function, and we call this view underscore tasks, and in the parameter we have tasks, and let's have this string literal. So displays tasks with colors based on priority. So there will be priority functionality as well. Now let's have a new line actually. So let's have \n here, and then let's have the equal sign for 30 times. So I'm gonna concatenate, so equal sign, and we want that equal sign for 30 times. Why is this comma here? Okay, then again let's write the print statement, and here let's have some spaces, then my to-do list. Okay, and again print the equal sign for 30 times. So let's write if not tasks. If there is no tasks actually, if that does not exist, then we want to print no tasks yet, add 1. However, if tasks exists, then we want to look through that. So I'm going to write for I or index, then the actual task, and let's use the enumerate to get the actual task and index at the same time, we have to use the enumerate. However, keep in mind that enumerate returns index first, so I would be at first, then the actual task, and we pass the tasks. Okay, now let's determine checkbox. Determine checkbox. So let's write a variable checkbox, and it will and in between double quotations I'll have these square brackets, and inside that the capital X. So the checkbox will look like this if the task is done. Okay? Else it will look like this. So blank square brackets. Now every task will have some priority. Now we need to determine color based on priority. So determine color based on priority. So let's have a variable p underscore color, and let's write 4 dot white. So this would be the default one actually. Then p underscore text, and we're gonna just have empty string. So now it's time to assign colors based on the priority. So if task priority equal high, that is the case, then p underscore color equal 4 dot red, and p underscore text equal, and in between parentheses, actually in between double quotations we will have parentheses, and inside them we will have 3 exclamation signs. So these tasks are very urgent. That is why we are indicating with the red color. Then we have elif and task priority, and if it is medium, then we want that p color would be 4 dot yellow, and p underscore text, and that would be in between double quotations and parentheses a single exclamation sign. And after that, let's have another elif statement, and if task priority equal low, that is the case, p color would be 4 dot green, and p text, actually let's not have any p text, so this has already green color, so it is not any kind of emergency, so we don't need that exclamation sign actually. Now this thing is done, the color things. After that, let's have another thing, that is strike through effect for done tasks, and that is using dimming color. So we are gonna handle if a task is already done or not. That's right, if task and it is done, that is the case, I want to print with string formatting obviously, and in the enumerate we have this index, but as index start with 0, we're gonna do I plus 1, then a dot sign, a period actually. It has nothing to do with the program, it is just for showing purpose. Then let's have this checkbox we created. As you can see, this checkbox thing, we put that variable here. Now let's have some styling. So I'm gonna write style dot dim, and text have task and the task name. Then let's write is done. So in between parentheses I'm gonna write done, and in between 2 curly braces I'm gonna write style dot reset all. Then I'm gonna write else and write the print statement again with string formatting, again I plus 1, then the period sign, then checkbox, but this time we'll have p underscore color because it is not done yet, it is undone, so we'll follow these colors. Okay, these ones, that is for task, and we use the task name. For that we just give the p text, meaning if it is high priority there would be 3 exclamation sign, if medium 1, and if low then no exclamation sign. Okay, so our view tasks function is done. So let's move to another function. So we are viewing tasks, but we don't have any function to add tasks, so that feels a little bit weird. So let's have that function to add task. So let's write def add underscore task, and in the parameter we have this tasks list, and there should be one variable name, and we're going to take that from the user. So I'm going to write input, and here I'm going to write enter task name, and For that, we want to strip that, and after stripping, if not name, then we want to print that task name cannot be empty, and we just return. Now, before adding the task, we want to ask the user the task priority. So let's have another print statement, and there we ask for the priority. And here capital H for high, then capital M for medium, and capital L for low. Now we have to ask the user for the preferred priority choice, and that is equal input, and let the user to choose. That would be inside double quotations, and after he gives his choice, we want to make that to lowercase. Now here the default priority would be low. Let's have this priority variable, and low tag is default. That means comment actually. This is not social media. After that, let's have some if-elif. So here I'm gonna write if p underscore choice equal h, then the priority would be high. Then elif statement, and here we check if p underscore choice equal m, then the priority would be medium. Okay. Now after the user gives this data, let's create the task object with those data. I mean a dictionary. So the task object dictionary actually, with respect to Python. In other languages, these are called object. So we're gonna call this new task, then equal curly braces. We give name as key, and for value we give the value provided by the user. So name. Okay. Then priority, and I give here the priority provided by the user, and initially the done property would be false. It is undone while adding actually. Then I can write task dot append, and I want to append new underscore task. After that, let's pass these tasks to the save tasks function. So let's pass them, and then let's print our string formatting. First of all, let's have some color. So 4.green task added successfully. Okay, now we will have two more functions. The first one would be toggle done. So this function will let the user to make a task done or undone. Then we will have another function to delete a task. First of all, let's define the toggle done function. Toggle underscore done, and we pass tasks, then view tasks, and we pass the tasks to this view tasks function. So user can view his tasks and mark them done or undone. So now let give the user to choose if he wants to mark it done or undone. So for that, let's have a try and except block. First of all, write the try block, and then num then equal, we call the integer function, and there we have this input function, and let's have a backward slash n for new line, and for placeholder write enter ask number to toggle. Okay, now here we will have some if statements. So I'm gonna write if 1 less than equal num less than equal. So this is chaining checking. So here I'm gonna write len tasks. Now in this block, let's see what we're trying to do. We are trying to switch true to false, or it is already false, then we'll try to make that true. So let's do that. So I'm gonna write tasks, and here I'm gonna write num -1. This -1 because that indexing thing. Then here I'm gonna write the done property from the dictionary. So done, and we want to modify that. So I'm gonna write equal not tasks again num -1, and right here done. So we are using this operator to reverse the value. And after that, it's time to save the tasks, and we have to pass the tasks, and then let's print status updated, and else if the input number is not in between this range, we want to print that it is invalid number. Now then I will have some except block, and here value error can happen. Let me write here print, and I'm going to write here please enter a valid number. Okay, so this function is also done, and after that we need another function to delete the task or a specific task. So let's define that. So def delete underscore task, and we have to pass the tasks. Now we have to call the view tasks function so user can view his tasks and make his mind which task he want to delete. So again here after viewing, let's have a try and except block, and here we want to ask the user which task he want to delete. So let's call the integer method. Inside that we pass the input function, and here let's have a new line, and for the placeholder I'm going to write enter task number to delete. Now here as well I will have this similar checking kind of, so I'm going to copy this and let's paste that here. Okay, so first of all we are going to check if the number is greater than 1 or equal to 1, and it should be less or equal to the length of the tasks. So if that is the case, we want to delete. Let me remove this part. Other thing will be similar, and here I'm going to write removed a variable actually, and here I'm going to write tasks dot pop num -1. This -1 because of that indexing thing. After removing that, let's call the save task function again and just pass the tasks. After that, I have to print the string formatting, and that is 4.red, I mean in capital letters, and let's tell that it is deleted. Okay, then the removed item, so removed task name actually, so name. Okay, and if it is not inside this range, then we pass or print it is an invalid number. If value error occurs, meaning he enters a string or other types of data, then it will print please enter a valid number. Okay, so our functions are done. So these will be executed when we call them, but there should be some code which will be called when we run the file. For that we want a main application loop, so the program should run if user does not stop that explicitly. So main application loop. Yeah, let's have a variable my underscore tasks, and let's first call load tasks function to load the tasks from the JSON file in this program. Then let's define the while loop. So while true, and I'm gonna write here view tasks, and let's pass my tasks, and let's have a bunch of print statements. So print, then /n for new line, and here I'm gonna write options, then again print statement, and here I'm gonna write that we are expecting A to add task. Now it is not any kind of special syntax. I'm writing to indicate the user that for A we are adding task. You can omit these square brackets, these are not necessary actually. Okay, then again print, and here I'm gonna write C in between double quotations actually, and here I'm gonna write C to mark complete or incomplete, I mean to toggle actually, complete or incomplete. Then print D, I mean select D to delete task, and user has to write Q to quit. And let's ask for the choice what he wants to do. So choice equal, and let's call the input function, and inside the input function we ask for the action, and let's convert that to lowercase, and after that let's check if choice is equal A. That is the case, then I'm gonna write add task and just pass my tasks, then write elif choice equal C. That is the case, we want to toggle the task and pass my tasks, again if choice is T, that means he wants to delete a task, and just pass tasks, my tasks. And let's have another if, and if choice is equal Q, then let's write print, let's write goodbye, and just break the loop. Okay, and if neither of them, so in the else block we just write print invalid option. Okay, so our program is finally done, and let's run this and hope for the best. Let me make this terminal bigger. As you can see, it is printing my to-do list, and as we don't have any tasks, it's telling no tasks yet, add one. This is coming from this view tasks function. As you can see, so when we run the program, we try to view the tasks, it trigger this function, and as you can see here, we are printing my to-do list and printing no tasks yet, add one. So let's try to add a to-do. So the action would be A. So here it is telling me the task. So the task should be coding. Hit enter. Priority should be obviously high. As you can see, the first task is coding, and it is not complete. As you can see, this checkbox is not checked, and the priority is high. That's why the text is in red letter and it has 3 exclamation sign. Okay, now let me add another task. Now this task is flip, and this can be medium. So as you can see, now I have 2 tasks, coding, then sleeping, and again add another, and we have to eat. Okay, and the priority would be low, but it should not be low. So hit enter. As you can see, I have 3 tasks. Okay, now let's mark sleep as complete. So I want to mark a task complete, so I'm gonna write here C, then hit enter, and it is asking enter task number to toggle. So the task number of sleep is 2. Okay, so if I write here 2, then hit enter, as you can see, this sleep is done, and you can see the checkbox is checked. Okay, again if I try to check this it, so let me mark that complete. So I'm going to write here C, and it will ask which task number I want to toggle. So this time I want to toggle the third one. If I hit enter, as you can see, it is also done, checked. And now let's say I want to toggle again, so C, and I want to uncheck this one. So let me write here 2, then hit enter. As you can see, sleep is not done yet, so it is unchecked, it is not complete yet. Now let's try to delete something. So let's delete the sleep one. So to delete, I have to write here D, then hit enter. Now it is asking enter task number to delete. So the task number of sleep which I want to delete is 2. So I'm going to write here 2, and hit enter. As you can see, the sleep task got deleted. And again, let's delete another D, and I want to delete coding. So give here 1 and hit enter. As you can see, now I just have 1 task. Now if I write here Q, then hit enter, it just finish the program executing. It says goodbye. So as a beginner, it was a quite nice and impressive program or project to build. I hope you understood many things in this project. If you really enjoyed this video, give a thumbs up and subscribe to this channel for future awesome videos. I'll put the code in my GitHub and provide the link in the description. So that's all for now. See you in the next project. Hey everyone, it's time to build our next project, and that is an university management system. So let's get started. So first of all, let me create a new project. I'm gonna call this University Management System. Okay, I'm gonna hit enter. We are not going to use any kind of package in this project. Basically, we'll be covering majority of the object-oriented programming concepts to build this project. So let me create a new Python file, and I'm gonna call this UMS. Okay, let me close the menu. Now here in this project, we will be covering everything you learned about object-oriented programming so far, till now. So if you think of a university management system, there will be some users or some person, and they can be student, they can be teachers, there can be courses, and student can enroll courses, there should be some grade, and etc. So first of all, we'll have some users or some persons in our system, and while dealing with these features, let's define a class, because as you know, in object-oriented programming, everything is about class and objects. So first of all, we'll be covering inheritance. So let's have a person class, which will be the parent class. So let's see the topic inheritance while building this project. First of all, let's have a class named person, and let's have a string literal describing what this class is for. So this is the parent class, and then we will have student class or professor or teacher class. They will share basic attributes from this person class. So both students and professors share basic attributes with person class. Okay, now we need a constructor, so let's have that. So def __ init. Not going too much in depth to make you understand this, I have videos on each of the topic in details in my playlist. You can check them out. So let me proceed a little bit faster here. And here we have the self parameter. As usual, we have this in every function of a class. Then we can have other parameters as well, like name, then age, and then email. Okay, so every person or user of the system will have these attributes. And now let's write self dot name equal name. So we are assigning these in the constructor self dot age equal age, then self dot email equal the email. Now let's have a display function or method which will be responsible to display the information of a person. So let's call this def display info, display underscore info, and here I can write print, and let's have a string formatting name, and here I can write self dot name, and it will also show the age as well. Let's make the A capital, and here it will have self dot age. Okay, so in case of inheritance, child classes will have attributes from the parent class. So let's create the child classes. For example, class student. Now it will inherit from the person class. In this case, the person class is the parent class. If you can recall the MRO system which we discussed in our in-depth videos. However, while learning inheritance inside this class, we will also discuss about polymorphism and encapsulation. So polymorphism and encapsulation. So in this class, first have our constructor. So dash dash init dash dash, and here we can have name, then age, email, and some extra thing, and that is student underscore id. Okay, now we have to use super here, which sends name, age, email up to the person class, to the parent class actually. So let's call the super method dot dash dash init, and let's have name, age, and email. So when we have a student, we must also have a person. So while we are trying to have a person, we need these properties to pass there, to the parent class. And here we have this unique field, which is the parameter student id. So here we have to write self dot student id equal student id. Okay, and a student can have some courses, so let's assign them as well. So self dot courses, and for the time being it will be an empty list. Now let's discuss about encapsulation specifically. So encapsulation. So in encapsulation, we'll have some private attributes or some private data which cannot be accessed directly from outside, and we do that by having two double underscores before the attribute. So here what I'm gonna do is I'm gonna write self dot underscore underscore grades equal blank curly braces. Now a student can enroll, so let's have a enroll function here after the constructor. So let's have this enroll method. We have self, and we have to pass course name, obviously, which a student can enroll. And I'm going to write self dot courses dot append, and let's pass course name, so that can be appended to the student. Okay, and after that we can also print something. Let me have some space here, and here we can print with some string formatting, and that is self dot name enrolled in course underscore name. Now by this method a student can enroll to a course. Let me have some spaces, and after that we need another method to add some grade to the student. So let's have that. So def add underscore grade, and let's have another parameters like subject, then the grade. Okay, now here we'll be controlling, so we control how data is changed, so there will be some validations. Now let's have some chain checking. So if 0 less than equal grade less than equal 100, if that is the case, meaning the grade is in between 0 and 100, we'll assign that to the grade attribute. So I'm going to write self dot underscore grade, grades that will be, and subject equal that provided grade in the parameter. And after doing that, let's print with string formatting, obviously, grade added for subject. Now if the grade is not between 0 and 100, so else we want to print invalid grade must be 0 to 100. Now in the student we will have another method to calculate his CGPA. So let's have this def calculate underscore GPA, and here I'm gonna write if not self dot underscore grades, I want to return 0.0 if grade is missing actually. Otherwise we want to calculate average and we want to return that. So return, let's call this round method, and here inside that we call the sum function, and let's pass self dot underscore grades dot values. Then let's divide with len self dot underscore grades. Okay, and after the period we want 2 digits, so we divide grade values with the grade numbers, so we get the average actually. Okay, this function is also done. Now it's time to understand some polymorphism. So we want to override a parents method. So let's have the method which is display info. As you can see in our parent class we have this method which is display info. Now we are having the methods and attributes from the parent class in this child class, but we can override those methods or attributes. So let's override this display info method, and here let's write this print statement and with a string formatting, and here in square brackets I print student, then self dot name, his name will be printed. Then we want to print his ID, so let's insert self dot student ID, and let's also print his CGPA, I mean the GPA actually, and let's print self dot calculate GPA, we call that method. Okay, so the features regarding our student class is done, like enroll, add grade, calculate GPA, and display info. Okay, now it's time to work with the professor class. Let's have some spaces and let's define our professor class. Class professor, and here we have this person, so we want to inherit the attributes and the methods from our person class. And here we will have our constructor, so dash init we'll have some more attributes like name, then age, then email, then for example employee ID, and then salary. Now we call this super method and just pass name, age, and email, because when we have a professor we must have a person as well. So we have to pass these attributes which are necessary to create a person. Okay, now it's time for the unique attributes specifically for the professor. So I'm gonna write self dot employee ID equal employee ID, then self dot salary equal salary. Now let's define some more functionality to a professor. So one feature can be that a professor got some salary increment. So let's define that functionality. So def give underscore raise, and here we should have the percentage, how much percent should the salary to be increased. Okay, after that here I can write self dot salary plus equal. Okay, let's do one thing. First of all, let's calculate the actual amount that would be increased. So let's have a variable called increase, and that would be equal to self dot salary multiplied by percentage divided by 100. And here I write self dot salary plus equal increase. Now I write the print statement with a string formatting, and here I print salary increased to, let's have a dollar sign, then let's insert self dot salary, and we want 2 digits after the floating point. Now let's do some polymorphism here as well. So let's override that display info method. So def display info, and here I want to print with a string formatting, for example professor, and the professor name actually. So self dot name, and let's print his ID as well, and let's print self dot employee ID, and let's print his salary as well. Let's have the money sign and self dot salary. Now after these classes we need a manager class which will have the system logic. So let's have a comment here. So manager class which will manage those previous classes or functionalities, and here we will have some system logic. So the system logic, and first of all here the class name would be university. Okay, now let's have our constructor, the def underscore init, and first of all let's have a uni name, meaning university name. So uni underscore name, and inside the class we initialize our attributes. So I'm gonna write self dot name equal uni name. By the way, you can call this uni name as well, but I'm gonna stick with just a name. And let's have this self dot people, initially empty list. Now this list can hold both students and professors. So this can hold both students and professors. Okay, now let's define a function to add a person to the university. So add underscore person, and in the parameter let's have the actual person will be added. So here I'm gonna write self, then the people list. So self dot people dot append, and we pass the person. And after doing that, let's print that message. So a string formatting, then I'm gonna write successfully added person dot name to the system. Now let's have another function to show all the people of the university. So def show underscore all underscore people, and in the function I want to print a string formatting /n for a new line. Let's insert self dot name, meaning the university name directory. So for p in self dot people, we're gonna write p dot display info. Now here Python automatically knows which display info to use with respect to the person, if he is a student or if he is a professor. Now let's have another function to find a student in the university. So let's write def find underscore student, and let's have a name, and let's write a for loop. So for p in self.people, so we check if the person is an instance of the student class. So we use the isInstance method. So if is instance, I pass p if p is instance of the student class, and p dot name dot lower equal the provided name in the parameter dot lower. If they both are same, we want to return that p, meaning the person, else just return none. Okay, so these will be executed when we call these methods, but there should be some code for main execution. So when we actually run the file, so for that, let's have this comment, which is main execution. Let's have some spaces, and here, first of all, let's have this variable, which is my uni, and let's use this class, which is the university class. So I'm going to write university, and for uni name, I'm going to pass the name Python Tech University. Okay, after creating this object from that university class, we want to print something. So print, and let's have this university system started. Now here, this program should be keep running until the user does not stops it explicitly. So let's use a while loop. So while true, and let's give the user some options. So first of all, the print statement, let's have a new line, so /n, and in the first option would be add new student. Okay, then the next option would be to add a new professor. We don't need a new line here, it will be auto added. So add new professor. Then let's have this, so show all people, so both students and teachers. Then let's have another print, and here we have some student actions. So student actions for enroll or grades. Okay, and lastly we have the option 5 to quit or exit. Okay, now let's ask the user for his choice what he wants to do. So choice equal input, and here let's have the placeholder select option. So after we get the choice from the user, we have to check if choice is equal 1. If that is the case, that means the admin of the management system wants to add a new student. So let's ask a name of the student actually. So name, then input, and in the input we have this placeholder name. Okay, now to create a student, we also need his age, and here we write input age. Okay, then we need his email, again the input function, and just email. Then obviously the SID or the student ID, and again call the input function, and just have this student ID. Okay, now after getting this data, we need to create an object with the student class. So we have to create object. So let's call this object S, and let's write student, and just pass name, then age, then email, then SID. So we got our student object. Now in the myUni object, which was created by this university class, we have this add person method. So we have to use that to add that person to the university. So I'm going to write here my_uni dot add person, and we just pass the student object. Okay, so the student add part is done. Now let's have this elif choice is 2, else if, meaning elif choice is 2, then the management person wants to add a professor. So to add a professor, we need to ask for name, age, and email. So what we can do is we can copy these 3 lines from here and we can paste them here. Okay, and extra we need EID, so the employee ID, and here we can have another input function, and for the placeholder we can say that it would be employee ID. Okay, and after that we ask his salary, and we write here the float method, so it will turn the input into floating numbers, and inside the float method we call the input function, and there for placeholder we have this salary. Now we have to create object with this data, so create object, and here I'm gonna write the object name P. Let's use the professor class, the professor, and let's pass name, then age, then email, then EID, and the salary. Let's have some shorter version. Okay, and after that I'm gonna write my underscore uni, I mean this object which we created from the university class, and here we want to call the method add person, and we just pass the P object. Okay, now for user options we have this third option, which is show all people. Now here let's have another elif statement. Elif choice is equal free, and here I'm gonna write my underscore uni dot show underscore all underscore people. Okay, after that let's have another elif. So if choice is 4, let's see what we want to do. Okay, so student actions, so make a student enroll a course or get the grades. Here in this block, first we want to target a student who will be targeted by the system manager person, and he will perform some actions. Let's ask for the student name, so target, I'm going to call the input function, and here let's ask to enter a name, so enter student name. Now here we have to find that student, so first let's have a variable called student, and how we find that student, so for that we can write here my uni dot, and if you see that my uni was created with this university class, and there in this class we have this find student function. Okay, so we can call that here, so my uni dot find student, and we can pass the name of the student, so target. Now here we check if student, meaning student was found in the system, then we want to print with a string formatting. Let's have a \n for a new line, and here we want to print accessing, then student dot name, and dot dot dot. So why is that squiggly lines below this name attribute? Oh, that is because we wrote student in capital letter, that would be in small letter. So this one, not the student class but this student variable. After that I want to print, so there the manager of the system has to make another choice. So if he wants to make an enrollment to a student or add a grade, so there would be two options. So option A would be enroll in course, then again the print statement, and the second option would be add grade. Now let's ask for his sub choice, so sub choice, so let's have this input function, and the placeholder would be action, and let's turn it to upper class. We always use lower, but this time let's do upper, and here let's check if sub choice equal capital A, then let's have a variable C, and there we expect a course name, so we ask the system manager the course name, so the placeholder would be course name, and after he gives the course name we call student dot enroll method and pass the course. Okay, let's have this elif, meaning the else if sub choice, and if that is equal B, here we will have a subject, so the administrator have to give a subject name in the input function, have this subject, then a grade variable, and here we call the float function, and in the input function we have this placeholder grade. Then we write student dot add grade, and we give the subject and the grade which will be attached. Now we were inside this if block, but if student was not found, we want to handle that in the else block, and here we just print that student not found. Okay, now this is done. After that, let's check if the option is 5 or the choice is 5. So elif choice equal that is 5, we'll just print saving. Now let's write saving data, then print system shutdown. So the process is finished and we just break the loop. And lastly, we write the else part. If choice was none of the above numbers, we want to print invalid choice. Okay, here I missed a colon, so there was an error. It got fixed. Let me run the file. I hope everything goes fine. Okay, so the program ran successfully. So university system started. So the manager has these options. So first of all, we have this add new student. So let's write here 1. So it is asking for student name. Let's say the student name is Adil and age is 22. Let's say email is adil@example.com and student ID is 101. As you can see, successfully added Adil to the system. So when the manager selected 1, so the program came here and started asking for these values. After that, it created a student object with these values, and here we have this myUni object. So it went there, as you can see, and he has to call the add person method. So from here it goes to the class and sees that method and executes that. Okay, now let's try to add a professor. So let me write 2, hit enter. It is asking for the professor name. Now the professor name can be, let's say, Hinata. Okay, age can be 30 and email can be hinata@uap.com. okay, now his employee ID can be E02 and his salary can be 30,000. Hit enter. As you can see, successfully added Hinata to the system. Now if I write here 3, it will show the students and the professor in our system. Okay, so why it is printing this F before the professor? Let me check. Okay, I have this double F here. Okay, if you remove that, this won't come here. Okay, now here the next choice can be 4, so we can perform some student actions. So if I write here 4, it will ask for the student name to whom we want to perform the actions. So here, as you can see, if the choice is 4, it is asking for the targeted student, and we have the student who is Adil, and if we hit enter, it will try to find Adil. So it found Adil in the system, as you can see, accessing student. So after it finds the student, so myUni.findStudent, this function got called. So after it found Adil, it is telling that accessing Adil, and now it is asking the administrator what action we want to perform. So is it we want to enroll in course or add grade? So first let's go with enrolling to a course. So it is A. So the course name would be DSA, I guess. So the course name would be DSA, I guess. So data structures and algorithm. If I hit enter, as you can see, Adil enrolled in DSA. Okay, so when it saw that the choice or the sub choice is A, it goes to the student object and calls the enroll function. As you can see, this enroll function. Now again, we can have some student action. So let's select 4 from here. Now again, let's access Adil. So it is accessing Adil, and this time we want to add some grade. So the sub choice would be B, and the subject is, let's say, DSA, and the grade should be 4.00. okay, now if I hit enter, as you can see, grade added for DSA. okay, now again let's choose 3 to see all the data with what we worked so far. If I hit enter, as you can see the data, you can see the GPA is 4.00. okay, so that is all we have in our program or the project. So now we can select 5 to exit the program. Okay, so I hope you understood everything discussed in the project. I hope you enjoyed this project and understood many things. So if you do enjoyed this video, make sure to leave a thumbs up and subscribe to this channel, and I will see you in the next one.